At first glance, time seems like the simplest thing in the world. You've got a clock, you've got a calendar, you've got seconds, minutes, hours, everything is neatly organized, everything looks like it works. Until you stop and ask one simple question: does a clock really measure time, or does it just measure change? Think back to that one day when you felt like doing absolutely nothing, sitting at work, staring at the wall, waiting for your shift to end. Time felt like it stopped. You looked at the clock, only 6 minutes had passed, but it felt like hours, and that wasn't a fluke. The next 5 times you looked, it was the same. Time was crawling. Now flip the situation. You're running late for your train. You glance at the clock, 7:23. You've got 10 minutes. You zip your bag, turn off the lights, put on your shoes. Next glance, 7:35. Time vanished. Seconds became minutes. Everything blurred. So time doesn't flow the same every time. It doesn't flow the same for everyone. It doesn't feel the same when you're waiting for it or when you're chasing it. So how can there be one time if we all experience it so differently? That leads to the real question: what does a clock actually measure, objective time, or just how much change happened since the last time you looked? But that's just the beginning, because physics says time doesn't just feel different, it actually flows differently depending on where you are and how fast you're moving. In 1971, an experiment called Hayfel-Keating was conducted. Two physicists took atomic clocks, the most precise clocks we have, and put one on a jet that flew around the world while the other stayed on the ground. When they compared them again, the clock that flew showed less time had passed, meaning the faster you go, the slower time moves for you. And this isn't a theory. This is an experiment, verified, measured, confirmed. But that's not all. If you're standing at the bottom of a building, time actually moves slower for you than for someone on the roof of that same building. Sounds insane, right? But the reason is gravity. The closer you are to the center of the Earth, the stronger gravity pulls and the more it slows down your time. GPS satellites orbiting the planet have to be adjusted daily because of this effect. Otherwise, their time and your time would drift apart. Enough that your GPS location would be off by several kilometers every day. So physically, objectively, measurably, time doesn't flow the same everywhere. That's why those satellites way up there need to adjust their clocks, because if they didn't, they'd show the wrong position. Their time isn't the same as your time down here. So if your time depends on your speed and your place in space, then there isn't one universal time for everyone. There's your seconds and my seconds, and they don't last the same. Then comes the next crack. If you can go forward in time, which physics confirms, why couldn't you go backward? Enter the grandfather paradox. Let's say you could travel back in time. You go and stop your grandfather from ever meeting your grandmother. That stops you from being born. But if you were never born, how did you go back to stop your grandfather? The whole system collapses. Cause and effect no longer make sense. If you can erase the thing that led to your existence, then time isn't a line anymore. It's not a sequence. It's not logical. And then comes the predestination paradox. You go back in time to stop something and end up causing it. You try to stop a fire, but your actions spark the first flame. Time becomes a closed loop. And again, cause and effect lose their order. There's no more before and after, just an endless loop. And if all this sounds like pure theory, take a look at quantum physics. At the microscopic level, time breaks even more. Quantum particles act like the now doesn't even exist. One particle can exist in both the past and future at the same time until you look at it. In the equations that describe the quantum world, time doesn't even show up. It's like it's unnecessary, useless. Even in attempts to unify quantum mechanics with general relativity, time is the biggest problem. We just don't know how to define it in a way that works across all levels of reality. Because if time isn't even required at the most fundamental level of the universe, then we reach the end. If your time isn't the same as mine, if time bends and breaks with speed and gravity, if experiments show there isn't one time but many, if in paradoxes cause and effect lose their sequence, if in quantum physics time doesn't even exist as a concept, then what is time? Is it a real entity, or is it just a tool we use to give ourselves the illusion that not everything is happening all at once? And when you look at the clock, do you see time passing? Or do you just see how much you have changed since the last time you looked? Mathematics is known as the universal language. You don't speak a language, forget words, give me numbers and we'll understand each other. 2 plus 2 equals 4. Always, everywhere, everyone knows that, everyone accepts it, no discussion. But what almost no one ever asks is, why is it 4? Who decided it should be exactly 4? Where did numbers come from? Did we discover them or invent them? You can question anything: what is love, what is consciousness, what is reality, and there's always some philosophical depends. But not with math. There's supposedly no depends in mathematics. Everything is exact, everything is precise, everything can be calculated, except when it can't. Why is it 4, why not 5 or 3 or some fraction? Who decided the world has to behave according to that rule? And more importantly, did we discover numbers or did we make them up? Because everything we call a universal language is actually a historical compromise. Not all civilizations used the same numbers. The Babylonians counted in base 60. Roman numerals had no zero. And zero, which we now treat as the foundation of everything, came from India more than 1,000 years ago, and at first Europe refused to use it because zero felt too dangerous, too abstract, too empty. So even what we now call basic wasn't always there. Numbers didn't fall from the sky. They weren't discovered like planets. They came gradually, evolved. People modified them, adjusted them, created new ones, which leads to a new question. If numbers didn't always exist, does math exist without them? And here you start to feel the first crack, because if something depends on history, on culture, on context, then it's not absolute. Let's go deeper. Imagine summing all natural numbers, 1 plus 2 plus 3 plus 4 forever. Your common sense says, obviously, it must be infinite, everything increases, there's no end, no boundary. But then in physics, specifically in quantum field theory and string theory, something else is used. The sum of all those positive numbers equals minus 1/12. Wait, how can you add only positive things and get a negative number? And no, this isn't a mistake. It's used in real calculations, in formulas describing the vibrations of subatomic particles, and it works. Precisely, consistently. It's not a paradox for fun, it's a tool in practice. So something that in school sounded impossible in physics is standard, and now comes the next hit. Infinity, in math, it behaves like a number. You write the symbol and people think it's just some super large value, but it's not. It's not a number, it's a concept. And the moment you try to calculate with it, everything breaks. Infinity plus 1, still infinity. Infinity times 2, still infinity. You can add whatever you want and nothing changes. That's not addition, that's nonsense. It gets worse when you try to subtract. Infinity minus infinity, that's where math throws its hands up. No result, it tells you undefined, doesn't know, not ready. And this is a system that's supposed to know everything. Even more strange is Hilbert's hotel. Imagine a hotel with infinite rooms and all of them are full, no vacancies. A new guest arrives, and you say, no problem. Every guest moves one room down. The first goes to the second room, the second to the third to the fourth, and just like that, room 1 is free. The new guest has a bed. In infinity, even when everything is full, there's always room. But what does that mean? Does infinity grow? Does it have a beginning and end? And why do we even use such a concept if we don't know how it really works? So you're using things you don't understand, and you act like you do. Now let's look at numbers like pi, 3.14, and digits that never stop, square root of 2. Euler's number, all of them are numbers without end. You can never finish them. You can never write them to the last digit. You can never fully know them, yet you use them. And you build on them bridges, airplanes, satellites, systems, and everything works. So you're using numbers you'll never truly know. And that's normal. That's what we call knowledge. Let's try a test. Imagine an architect building a bridge using a number he doesn't know how long it is, doesn't know where it ends, just knows it works. And you walk across that bridge and trust it, because math doesn't make mistakes. But how do you know it's not wrong if even you don't know the number? Kurt Gödel was a mathematician from the 20th century, one of those who changed everything we thought we knew about logic and proof. He wasn't someone who invented numbers or solved equations. He asked a deeper question: what can mathematics actually prove? And can a mathematical system verify itself from within? And he found an answer that, for many, was shocking. Gödel proved that every mathematical system strong enough to describe basic things like numbers and addition must contain statements that are true but cannot be proven within the system. In other words, you can have a system that works perfectly, that gives correct results, that solves problems, but there will always be something that is true and you cannot show it. Not because you're not smart enough, not because data is missing, but because it's built into the system, structurally. It's like having a book that contains all mathematical truths, but inside it there's a sentence that says, this statement cannot be proven. And if you try to prove it, the system collapses. If you say it's false, it still collapses. So it's true but untouchable. That's what we call Gödel's incompleteness theorem, and it changes everything. Because until then, people believed that mathematics was a closed world, that if you know the rules, you know everything. That everything is solvable if you just try hard enough. Gödel said, no, not all truths are reachable, not all answers can be proven, and that's why even in a perfect system there are holes, not as mistakes, but as a natural consequence of having rules. A system that works, but one where you can never be sure how much you truly know, or what you're missing. So if there are numbers you can't mathematically calculate, and if infinity doesn't actually follow the rules of mathematics, is mathematics really the universal language of the universe, or just a human invention made to explain what we couldn't understand any other way. Everyone thinks they know what infinity means, or at least they act like they do. You say the word infinite and heads nod instantly. It's supposed to be obvious, something with no end, something that goes on forever. But the moment you stop and actually think about what that means, everything starts to break. Because if something has no end, how do you know it's infinite? If you can't count it, if you can't reach the edge, if you can't define where it starts or finishes, what exactly are you measuring? How do you know that you're even inside infinity and not just very far from the end? The second you try to grab it, it slips, it stops being a concept and becomes a whole. They say the universe is infinite, but in the same breath, they say the universe is expanding. Think about that for a second. If something is already infinite, what does it mean to expand? If it was smaller yesterday, then it wasn't infinite yesterday. If it will be bigger tomorrow, then it's not infinite right now. If something is becoming infinite, then by definition, it's not infinite yet. Because you can't be halfway to forever. You can't be on your way to endlessness. Either it already has no limits or it does. You can't have both. So if the universe is still expanding, it's not infinite, or if it is infinite, then it can't expand. And yet both of those statements come from physics, from science, from people who are supposed to know what they're talking about. That's not a paradox. That's a contradiction. And it gets worse with time, because people say things like forever, eternal, timeless, as if time just stretches out like a hallway. But time doesn't stretch, it ticks. It moves forward one slice at a time, second after second, step by step. And here's the problem: at every step, you're still inside time. You're never at the end, you're always at some point. Which means even if something lasts forever, you're never in forever. You're always in now, and now is never infinite. Infinity through time is a moving target. It's never this moment. It's always somewhere else. It's a promise you can never reach. And here's where it breaks even more in math. Infinity in mathematics isn't even a number. It's a symbol, a placeholder, a patch for when the system runs out of answers. Try to treat it like a number and math stops playing along. Infinity plus 1 equals infinity. Infinity times 2 equals infinity. Infinity minus infinity, undefined. The whole system throws up its hands. It doesn't compute. You hit the wall. There is no next number after infinity. There is no limit you can cross. It's not a step. It's a stop sign. And yet we use it every day. We draw the symbol like it's just another part of the toolkit. But the truth is, once you write that loop, that sideways 8, the calculation ends. It's not logic. It's a dead end. It's a polite way of saying we have no idea what comes next. And just when you think it couldn't get stranger, enter Hilbert's Hotel, a thought experiment created by mathematician David Hilbert. Imagine a hotel with an infinite number of rooms. Every single room is full, no space left, but then a new guest arrives, and the manager says no problem. He tells the guest in room 1 to move to room 2. Guest in room 2 goes to room 3. Guest in room 3 goes to room 4, and just like that, room 1 is free. The hotel was full. And yet there's still room. That makes sense in math, but not in reality. You can't be completely full and still have space. That's not logic, that's a glitch. But that's what infinity does. It lets the impossible sneak in. And here's the part no one likes to admit: no one has ever seen infinity. Not in space, not in time, not in quantity. You've never touched something infinite. You've never measured something that had no limit. You've never experienced anything that never ended. And yet you use it, you believe in it. You plug it into equations as if it's just another variable. Ask any physicist if infinity is real and you'll get the same answer. In theory, maybe. In the real world, probably not. And some theories go even further. In quantum gravity, there's something called Planck length. It's the smallest possible unit of space, around 1.6 times 10 to the negative 35th meters. Smaller than that, and space itself loses meaning. You can't go below that scale. There's nothing smaller, which means space might not be infinitely divisible. You can't zoom forever. There's a bottom, a hard stop. And in black hole physics, there's something called the Bekenstein-Hawking entropy formula. It says that a black hole has a finite amount of information, a limit. Even if it looks like an infinite void, it only contains a certain number of bits, which means the most extreme object we know is not infinite. And then there's the holographic principle, the idea that all the information in a volume of space is actually stored on its surface. Which means the universe, even if huge, could be finite in how much it can contain, not because it ends somewhere, but because the information capacity has a cap. And yet we keep throwing infinity into equations like it's harmless, like it belongs. But what if it does? What if infinity is just a mathematical illusion, a stand-in for we don't know? What if infinity is not a number but a confession? Because when you say something is infinite, you're not describing it. You're admitting that you can't. So if you've never seen infinity, if no object in nature proves it exists, if the smallest scales of space have limits, if black holes have maximum information, if the equations break the moment you subtract or divide infinities, if math uses it but can't control it, if physics relies on it but can't prove it, then maybe the question is, what is infinity? Maybe the real question is this: If infinity can't be measured, seen, reached, or proven, why do we believe it more than the things we can? Logic sounds like the most reliable tool we have. If A then B, if B then C, so A leads to C. Clean, predictable, solid, it feels like a perfect chain. Use it in math, use it in science, use it when arguing with your friends. As long as it's logical, it must be true, right? But what if logic can't explain what's actually happening? Then maybe the world isn't broken, maybe logic is. Let's start with something simple. You're at a red light, it turns green. Logically you go, that's the rule, that's the signal. Green means go, except a truck runs the red light from the side and hits your car. Now explain what happened. You did everything logically. You followed the rule and you still ended up in a crash. That's because logic doesn't guarantee safety. It doesn't guarantee truth. It only follows rules, and rules don't always match reality. You can logically argue that free will doesn't exist, that every choice is the result of past causes, brain chemistry, and physics. You can show charts, cite studies, build airtight arguments, but tomorrow you'll still choose what to eat for breakfast. You'll still hesitate before answering a hard question. Your body might be a machine, but your experience is. So even if the logic says your choices are illusions, the feeling of choosing is still real, and that means logic can describe systems. But it doesn't always describe life. Because logic doesn't care if something is real, it only cares if something is consistent. You can build a logical argument to prove that the world doesn't exist, that everything is just a simulation, that nothing is actually real, and your logic might be flawless, but you're still here, breathing, existing, experiencing. So the fact that an argument is logical doesn't mean it's true. Logic is about form, not content, and that means it can be perfectly structured and completely wrong. Now let's talk about paradoxes, the cracks in the wall. The moments where logic tries to explain something and explodes. Try this sentence is false. If it's true, then it's false. But if it's false, then it's true. That's not just wordplay, that's a full system error. Logic can't resolve it, it loops forever. And that loop means the structure breaks. That's not just a weird puzzle, it's a statement logic can't answer. Then there's Russell's paradox. Imagine a list of all lists that do not contain themselves. Does that list contain itself? If it does, then it shouldn't. If it doesn't, then it should. Again, logic crashes. These paradoxes don't break reality, they break logic, because if there's even one sentence that logic can't process, then logic isn't complete, and that leads us to Gödel. Kurt Gödel was a mathematician and logician who proved something terrifying. He showed that in any logical system that's strong enough to do math, there will always be true statements that cannot be proven within the system. Let that sink in. That means you can have a system where something is 100% true, but you will never be able to prove it using the system's own rules. Logic doesn't know what it doesn't know, and worse, it can't find out. You could be completely right, and the system would never tell you. It doesn't have the tools, not because it's broken, but because the rules themselves guarantee that certain truths will stay hidden. That's Gödel's incompleteness theorem, and it doesn't just apply to math, it applies to every structure based on logic. It means, no matter how smart you are, how perfect your logic sounds, how carefully you built your argument, some truths will never be provable, not because you're wrong, but because proof isn't always possible. So ask yourself, if you don't know that you know, do you really know anything? And here's the kicker. If you use logic to prove that something is not logical, what exactly have you proven? That logic failed, or that you're stuck inside a system that doesn't reach far enough? If the very tools you use to find truth are the same tools that declare themselves incomplete, then what are you building? This is where it gets uncomfortable. Because if you've understood everything in this video, if the paradoxes made sense, if Gödel's theorem clicked in your mind, then you followed logic all the way to its own limits. You used logic to understand that logic breaks. So either you've discovered something beyond logic, or you've just looped back into a trap. So maybe logic isn't the master key. Maybe it's just a frame, a useful, powerful, elegant frame, but one that cracks the moment reality pushes from the outside. And if that's true, if logic can be internally consistent and still not explain the world, then maybe the question isn't whether something is logical. Maybe the real question is, what happens when reality doesn't care about your logic? Everyone feels like they're in control. You wake up, pick your clothes, decide what to eat, choose what to say. Every move, every thought, it feels like it came from you, like you had a choice. That's what free will is supposed to be, the ability to choose freely, to act without being forced. But what happens when you look underneath that feeling? Start with something simple. You're standing at a vending machine. You want a snack. You look chips or chocolate. You pause, then you pick chocolate. Feels like a choice. But why did you pick it? You might say, I just felt like it. But what made you feel like it? Was it your mood, your blood sugar, a commercial you saw last night? your memory of how good it tasted last time, because all of those things are outside your control. You didn't choose your cravings, you didn't choose your brain chemistry. You didn't choose what popped into your head at that moment. So did you choose, or did something choose for you? Now zoom out, think about every decision you've ever made. Your job, your partner, your beliefs, go deep. Why did you choose them? Because of your personality, your past, your preferences, but your personality was shaped by your genes and environment. Your past you didn't pick. Your preferences came from experiences you didn't control. So if every layer of you was built by things outside of you, where does your choice begin? Neuroscience adds another crack. In lab experiments, researchers have wired up people's brains while asking them to make simple decisions, like pressing a button with the left or right hand. And what they found is shocking. Brain activity predicting the decision happens before the person is even aware of making the choice. In other words, the brain decides, then the person feels like they decided. But the brain already knew, several hundred milliseconds before, so who chose? Let's take it further. Say you believe in full free will, that you can always choose, then explain your next breath. Are you choosing to breathe right now? Or is it automatic? Try to stop, your body will force it back. You're not in control, and yet you feel like you are. That's the illusion. Now let's test it with a bigger example. Imagine someone grows up in a dangerous neighborhood, parents absent, violence everywhere, education terrible, role models gone, survival becomes priority. That person grows up, gets into trouble, maybe even crime. Now ask, did they choose that life, or was it chosen for them by the circumstances? Could they have chosen differently if nothing in their life showed them a different way? Flip the example, someone grows up in a safe area, good school, stable family, encouraged to explore, supported emotionally. That person ends up successful, smart decisions, clean record. Did they choose that, or was it also chosen for them? Because if free will means we're responsible for our choices, but those choices were shaped by things we didn't choose, what does responsibility even mean? But here comes the twist. Even if we say everything is determined, that every action is just the result of previous causes, that doesn't match how it feels, because we feel choice every day. You pick what to wear, you pause before you speak, you weigh options, you hesitate, you reflect. All of that feels like freedom, and the feeling is real even if the mechanism is not. So now you've got two layers. The external layer, science says your choices are determined. The internal layer, you feel like you're choosing, and they clash. Now look at legal systems. Courts punish people for bad choices, reward good ones, but if no one actually chooses, how can you punish anyone fairly? You're punishing outcomes, not intentions, because intentions weren't chosen. Same with praise. Someone wins an award, writes a book, builds a company, and we say, they worked hard, they earned it. But what if their drive, their focus, their grit all came from their biology and background? They didn't choose to be ambitious, they just were. That leads to an even darker place. If you think you're in control, you judge others more harshly. You say, they should have worked harder, they should have made better choices. They're lazy, irresponsible. But if they never had your upbringing, your chances, your brain, maybe they never had the option to be like you, so is it fair to blame them? And what about you? If everything you are, your work ethic, your kindness, your patience, came from somewhere else, do you still deserve the credit? And yet, even knowing all of this, you will still feel like you choose. You'll still pause before a hard decision. You'll still say, I decided. So maybe the question isn't, do we have free will? Maybe the better question is, if all our choices are made before we're aware, if brain scans can predict your decisions, if your upbringing shaped your every reaction, if your beliefs came from your environment, if you feel like you're choosing but never picked the things that made you who you are, then what exactly is you? And if you didn't build you, then who's choosing now? Correlation isn't causation. If the model breaks at the beginning of the universe, then maybe cause and effect isn't a law. Maybe it's just a story we use, a way to organize chaos, a shortcut for the mind. And if that story starts to fail, maybe it's time to ask, are we chasing causes because we want answers, or because we're afraid to admit that some things just happen? Cause and effect sounds simple. One thing happens, it causes another. You turn the key, the engine starts. You drop a glass, it breaks. It's clean, logical. First comes cause, then comes effect, always in that order. But the moment you dig deeper, the cracks start showing. Start with something basic. You sneeze and someone says, bless you. Did your sneeze cause the blessing? Technically, yes, but did you control it? No. The sneeze happened, the response followed. Now scale that up. You miss a bus, which makes you late to work, which gets you fired, which changes your entire life. All of that from one misstep. So which part was the cause? The alarm clock, the traffic, the fact that you were tired the night before? Or was it the argument you had 3 days ago that drained you? The chain never ends, and that's the first problem. Cause and effect aren't lines. They're webs. Try to pinpoint where anything really starts and you're lost, because every cause has its own cause. And that cause has a cause too. It doesn't stop. It goes back forever. That's called infinite regress, and it breaks the whole model. If you need a cause for every cause, you'll never find the first one. You'll always be searching behind the curtain, but it gets worse. In quantum physics, cause and effect break completely. Sometimes particles act like the effect happens before the cause. A particle reacts before it's been touched, or collapses before it's been observed. It's not science fiction, it's real data, verified in labs, and it makes no sense. Because if the effect comes first, then what's the cause? Even more strange, in some quantum experiments, the act of measuring decides what the result is. As if the effect reaches backward in time and creates its own cause. That's called retrocausality, and it shatters the whole idea of order. But even in daily life, cause and effect get messy. You smile at someone and they smile back. Did you cause their smile? Were they already smiling? Did you trigger it or just match it? And if they smiled because you smiled, did you only smile because you wanted them to smile? It loops, it's not clear, and that's the problem. In real life, effects cause new causes. Feedback loops happen. You raise your voice, someone raises theirs. Now who caused what? The effect becomes a new cause, which causes a new effect. And the cycle spins, no clear beginning, no clean line, just reaction after reaction. Now think about psychology. You feel anxious, you avoid a task, that makes you more anxious. The avoidance is an effect, but it becomes a cause, and now you're stuck. In a loop you didn't choose. The original cause might have been small, but it triggered a cycle, one that feeds itself. Cause becomes effect, effect becomes cause. That's not a line, that's a trap. Same with trauma. Something happens to you as a child, that's the cause, but it changes how you act, think, feel for decades. You get defensive, closed off, reactive. You hurt others. And then they hurt you back, so now your reaction causes new pain, which reinforces the trauma. The original cause fades, but the effects become new causes. The pattern continues even if the starting point is long gone. Now zoom out to society. Poverty leads to stress. Stress leads to bad health. Bad health leads to lower income. Lower income leads to more poverty. Again, the line turns into a loop. Which one is the cause? Which is the effect? It doesn't matter, because they reinforce each other. The system sustains itself, and you can't just fix one side. You have to break the cycle, and that's hard. Because most systems, emotional, social, physical, are built on feedback, not one direction, not cause then effect, but loops, spirals, delays, and that's where our brains struggle. We want clean stories. This happened because of that, but the truth is rarely that simple. You might blame your failure on one mistake, but maybe the real cause was 10 tiny things weeks earlier. You might think your success was from hard work, but maybe luck, timing, genetics, or someone else's help played just as big a role. We love cause and effect because it gives us control. It says, do X and you get Y, but the world doesn't always work like that. Sometimes you do everything right and still fail. Sometimes you do everything wrong and win. Cause doesn't guarantee effect, and effect doesn't prove a cause. That's why in science we say, correlation is not causation. Just because two things happen together doesn't mean one caused the other. Ice cream sales and drowning both increase in summer. But ice cream doesn't cause drowning. The link is hidden, it's the weather. So even when patterns look clear, the cause may be invisible, or there may be many, or none, and that's where philosophy kicks in. What caused the universe? What caused existence? If every effect needs a cause, then what caused the first cause? And if the first cause doesn't need a cause, why is it different? You either have infinite causes or you say something came from nothing. Both are impossible. And yet one must be true, which means cause and effect can't explain everything. They hit a wall, so here's where we land. If every cause has a cause, if effects become causes themselves, if time loops backward in quantum systems, if psychology traps you in cycles, if social problems feed themselves, if science can't find the first cause, if correlation isn't causation. If the model breaks at the beginning of the universe, then maybe cause and effect isn't a law, maybe it's just a story we use, a way to organize chaos, a shortcut for the mind. And if that story starts to fail, maybe it's time to ask, are we chasing causes because we want answers, or because we're afraid to admit that some things just happen? Perception feels like truth. You see something, it's there. You hear a sound, it happened. You feel pain, it must be real. But the moment you scratch the surface, you realize perception isn't reality. It's just a version of it, filtered, edited, and often wrong. Start with something simple. You see the sun move across the sky, east to west, every day. So the sun must be moving, right? No, it's the earth spinning. But your perception says otherwise. Because your senses weren't built to detect the Earth's rotation. They were built for survival, for noticing tigers, cliffs, and food, not for decoding cosmic motion. That's the first crack. Your senses aren't neutral, they're biased. They only give you what's useful, not what's true. Now think about sound. You're at a party, dozens of voices, music, glasses clinking. Yet someone says your name from across the room and you hear it, instantly. That's called the cocktail party effect. Your brain filters the noise and highlights what matters. You didn't hear everything. You heard what you were primed to hear. That's not full perception, that's selective perception. Your brain edits reality before you even notice it. And it does this all the time. Look at optical illusions. Two lines the same length, but one looks longer. A still image that seems to move. A cube that flips orientation when you stare at it. Your eyes see the same data, but your brain interprets it differently. Which means what you see is what's there. It's what your brain thinks is there. Now add memory to the mix. You don't remember things as they happened. You remember fragments, highlights, emotions. And every time you recall a memory, your brain rewrites it slightly, adds details, changes context. You think you're replaying a video, but really you're editing a story over and over. So now you're not even perceiving the past clearly. You're perceiving a reconstruction, and it gets stranger. In 2015, scientists tested perception with a famous dress photo. Half the people saw it as blue and black, the other half as white and gold. Same image, same data, completely different perceptions. Why? Because your brain guessed what the lighting was and made a decision. You didn't choose to see it a certain way. Your brain just picked one version. That's perception, not truth, but interpretation. Now think about pain. Two people get the same cut. One screams, the other shrugs, same injury. Different pain because perception of pain depends on expectation, attention, emotion, even past trauma. The body sends signals, but the brain decides how loud they are. That's why placebos work. Sugar pills can reduce pain if you believe they're medicine. Your belief changes your brain's chemistry. That's perception bending biology. And it works the other way too. Nocebo effects. If you expect a side effect, you might feel it, even if the drug is fake. The perception of danger creates real symptoms. Dizziness, nausea, anxiety, so your brain can turn imagination into sensation. What about time? We already said in the time segment, time feels slower when you're bored, faster when you're busy. That's perception too, because your internal clock doesn't tick like a machine. It speeds up, slows down, stretches, compresses, based on how engaged you are, based on how much you remember. That's why long days can feel short in memory, and short days can feel eternal. You don't experience time. You experience your version of time. Now step into fear. You're walking at night. You hear a noise. Suddenly, every shadow looks like a threat. Every shape looks human. Your heartbeat rises. Your senses sharpen. That's perception hijacked by emotion. The world didn't change, but your experience of it did. Because fear doesn't wait for facts. It changes what you see, and it does it fast. Then there's attention. Try this. Count how many times players pass the ball in a video. You focus, you count, then someone asks, did you see the gorilla? You didn't. Even though a man in a gorilla suit walked through the middle of the scene, you missed it. Not because you weren't looking, but because you weren't expecting it. That's inattentional blindness. You only see what you look for, and what you look for depends on expectation, on context, on goals. So even your awareness is shaped not by what's real, but by what matters to you. Now think about emotion. When you're sad, everything looks gray, songs sound deeper, the world feels heavier. But when you're happy, the same street looks beautiful, same setting, different mood, different perception. That's not just poetry, that's neurology. Your brain literally interprets the world differently based on mood. So your state changes your sense, and that means no one sees the same world. Everyone's perception is different, and not just by a little, by a lot. Culture changes perception too. In some cultures, eye contact is respect. In others, it's aggression. The same behavior afferent meaning, because perception is learned, shaped, trained. Even color perception varies. Some languages have no word for blue. Some tribes in Namibia see greens we can't even distinguish, but can't separate blue from black. Their brains see differently because their words shape what they notice. That's called linguistic relativity, and it suggests language changes perception. So what does all this mean? If your eyes lie, if your ears miss things, if your memory rewrites events. If your expectations shape your senses, if your mood filters what you feel, if your culture decides what's normal, if your language controls what you can describe, then what are you actually perceiving? Not the world, just a version of it. Your version, edited, personalized, filtered by biology, emotion, culture, and expectation. So when two people argue about what really happened, maybe they're both right, or maybe they're both wrong, because they didn't experience the same thing. They experienced their own perception of it, and that perception is never the whole picture. So the question is, what did you see? The question is, what did your brain let you see? And if your brain filters everything, then how would you ever know what's really out there? Maybe perception isn't a window to the world. Maybe it's just a mirror, reflecting back the assumptions you already had. Reality feels like the one thing you can't question. You touch it, you live in it, it surrounds you. You fall, you bleed, you wake up, you work. What more proof do you need? But then something strange happens. You hear two people describe the same event and they remember it completely differently. You watch two news channels and they report two opposite truths. One person sees a hero, the other sees a villain, and both believe they're right. So what's going on? If reality is one fixed thing, why does everyone seem to live in a different version of it? Let's start with the basics. Your brain doesn't interact with the world directly. It sits in your skull in complete darkness. It doesn't see, it doesn't hear, it doesn't touch. All it gets are electric signals. From your eyes, your ears, your skin, your senses pick up data and your brain builds a picture, a guess, a best estimate. That guess is what you call reality. But it's not raw input, it's processed, translated, edited, and that means it can be wrong. You think you see the world, but really, you see your brain's model of the world. Take color, you look at a red apple. You think the apple is red, but red is not a property of the apple. It's just how your brain interprets light waves bouncing off it. The apple reflects light at a certain frequency. Your brain turns that into red, but that's just your system. Other animals see different colors. Some birds see ultraviolet, some snakes see infrared. The world hasn't changed, but their reality has, because reality is what's out there. It's what you can detect from what's out there. Now take dreams. You're lying in bed, eyes closed, not moving. And yet in your dream you're flying, running, talking to people, feeling fear or joy or pain. Everything feels real until you wake up, then it vanishes. But while it was happening, it was your reality, which raises the question, how do you know you're not dreaming right now? What makes this moment more real than that one? Your senses, your memory, your body, but all of that exists in dreams too. Think about illusions. You put a straight stick in water, it looks bent. You stare at a still image, it seems to move. You feel your phone vibrate in your pocket, but there's no message. Your senses fail you all the time, but you still trust them. Because what else can you trust? If you start doubting your perception, then reality becomes unstable. And that's where things get even weirder. Take quantum physics. At the tiniest level, particles don't behave like solid things, they behave like probabilities. They exist in multiple states at once until you observe them. Your act of measurement changes what's real. Before you looked, the particle was in a cloud of possibilities. After you looked, it collapsed into one outcome. So reality doesn't just exist independently, it interacts with observation. It's not fully there until someone watches. Now think about consensus. People say reality is what everyone agrees on. But what if everyone agrees and they're all wrong? For thousands of years, people believed the Earth was the center of the universe. That wasn't a fringe opinion, that was the mainstream. The scientific, educated consensus. It was also completely false, so agreement isn't enough. Even collective belief can create a false reality. Or go deeper, what if reality is just information? In physics, there's a theory that the universe might be like a giant computer, a simulation running on physical laws. Everything you see is data, processed, stored, interpreted. That doesn't mean someone's controlling it. It just means reality might not be solid stuff. It might be code. If you zoom in far enough, space becomes pixels, time becomes frames, matter becomes bits. That's not science fiction. That's digital physics. Some serious scientists actually consider it. But even if it's not a simulation, think about what that idea shows. That reality might not be what it feels like. You think it's a room, a planet, a moment, but underneath it might be patterns, formulas, logic, and the only thing that makes it real to you is your experience of it. Now take social reality. Money, nations, laws, rights, none of these exist in nature. You can't find $20 in a forest or freedom under a rock, but they feel real. You can spend money, get arrested, be protected by a right, so they affect your life. And that makes them real in a different way. Real not because they exist physically, but because we believe in them together. We've all agreed to treat them as real, and that shared agreement makes them powerful. That's called intersubjective reality. It's not in your head, it's not in nature. It's in the space between, created by minds working together. Then there's virtual reality. You put on a headset, suddenly you're in another world. Your hands move, your body reacts, your heart races. You know it's fake, but your body treats like it's real. That's how thin the line is. A screen, some code, and a headset, and your sense of reality changes. So how do you define what's real? Is it what you can touch, feel, believe, share, experience? Now think about your memories. Your past is a huge part of your sense of reality, but memory is fragile. Every time you recall an event, your brain changes it a little. You remember things that didn't happen, forget things that did, add details, remove others. Over time, the original moment is gone. What you remember is your memory of the memory. So your reality, your personal timeline, is built on unstable ground, on stories you keep rewriting. And now the internet, social media creates bubbles. Algorithms show you what you already agree with. You see your version of the world again and again until it feels like the only one. Someone else lives in a different bubble, sees different news, different ideas, different facts. And now you both live in separate realities on the same planet. At the same time, that's not a glitch. That's the system working exactly as designed. So what do we do with all this? If your senses can lie, if your dreams can feel real, if particles change when you look, if society agrees on things that don't exist in nature, if memory shifts, if technology bends your experience, then what is reality? Is it what stays when you stop believing in it, or is belief part of the equation? Maybe reality isn't one thing, maybe it's layers: physical, social, personal, emotional, shared, private. Maybe reality is a network of overlapping models, all incomplete, all imperfect, but useful enough to help you survive. And maybe that's the point: reality isn't what exists, reality is what lets you act, predict, respond live. So next time someone says, be realistic, maybe ask, whose reality do you mean? Because if every brain builds its own version, if every culture shapes its own truths, if every second you're filtering, guessing, editing, and reacting, then the real question isn't what is reality. It's how much of what you call reality is just your reflection playing back at you. You wake up in the morning, open your eyes, and there it is, the quiet feeling of I'm me. Not a question, not a theory, just a certainty. You don't have to think about it, you just are. But if you stop for a moment and really try to define who or what this I is, everything starts to shift. Is it your name, your memories, your body, your voice, your choices? Because all of those things change. And if they change but you still feel like you, then who are you really? Start with your name. You didn't choose it, someone else gave it to you. If you had a different one, would you be a different person? If everyone started calling you by a new name tomorrow, would something inside you change? Probably not. So the name isn't you, it's just a tag. What about your memories? They feel personal, real, solid, but as we've seen, memory lies. You forget, you misremember. You rewrite your past every time you tell a story. You've probably believed things about yourself that later turned out false. So if memory isn't reliable, is it still part of you? If you lost all your memories in an accident, are you still you? Or is your identity tied to remembering your past? Now try your body. That should be simple. You are your body, right? But your body has changed completely since you were born. Every cell, every bone, you've shed skin, grown taller, changed shape. Even your brain, the thing you think with, has rewired itself thousands of times. New neurons, new connections. The body you had 10 years ago is not the body you have now. So if your body keeps changing, but you still feel like you, then identity can't be just physical. Maybe it's your choices, your personality, but who you are when you're tired isn't who you are when you're confident. Who you are with your best friend isn't who you are with your boss. You shift depending on the situation. Act one way with one person, a totally different way with another, so which version is the real you? Now let's go deeper. Imagine a copy of you is made, same face, same memories, same habits. It thinks it's you, feels like you, but you still exist too. So which one is the real you? If there can be two, then what does that say about the original? Is identity just a pattern, a structure that can be duplicated? Or let's go sci-fi. Your brain is gradually replaced by artificial neurons. One by one, slowly, each new part works exactly like the old one. At no point do you stop functioning, no moment where you disappear. But in the end, nothing biological remains. Is the result still you? If you say yes, then identity is function, not flesh. If you say no, then when exactly did you stop being you? And this isn't just theory. In real life, people lose parts of their body, their memories, their personality changes from trauma or illness, and yet we say they're still the same person. So clearly, identity isn't one thing, it's more like a story, a thread. Something weaves through the chaos and says, this is me. But here's the twist: you don't control the story. You don't choose where you're born, what you look like, how your brain is wired. You didn't write your genetics. You didn't design your environment. You just showed up. The story was already rolling. You took the wheel halfway. And even then, most of your thoughts happen automatically. Studies show decisions start in the brain before you're aware of them. Your sense of free will kicks in after the brain has already acted. You say, I chose this. But maybe your brain chose, and you just narrated it after. So who's driving? Now think socially. Identity is never built in a vacuum. You are someone's child, someone's friend, someone's employee, someone's partner. The roles you play shape the self you feel. Strip them away and people lose their sense of who they are. That's why retirement, breakups, moving to new countries feel like identity crises, because so much of you was built through others. You reflected their expectations, their language, their reactions. So the self isn't sealed, it's relational. Let's add one more layer: performance. You perform your identity, the clothes you wear, the words you use, the music you like. It's not fake, it's selected, edited, curated. Some parts you show, some parts you hide, and over time that becomes the you people know. But if you had grown up in a different culture with different rules, different pressures, would your identity be the same? Probably not. So even what feels deeply you might just be what fit best in your surroundings. And then there's the inner voice, that running dialogue in your head, the thoughts that sound like you. But where do those thoughts come from? Can you control them? Can you stop them? Most people can't. They rise on their own. You observe them, react to them, and call that reaction self. So maybe identity isn't one thing. Maybe it's a loop. A memory reacting to a thought, reacting to a role, reacting to a story. A system watching itself, updating itself, mistaking the process for a person. And yet something persists, through all the changes, through all the confusion, a thread, a presence, a continuity. You can't define it, but you feel it. And maybe that's what I really is, not a thing, not a substance, but a process, a flame that keeps burning even as the fuel keeps changing. So what is identity? Is it your past, your body, your thoughts, your story, your function, your name? Or is it just the echo of a question you can never quite answer, but still ask every morning when you wake up, and feel that quiet, steady voice say, "This is me"? You hear a rumor, you check the source. You look it up online. You scroll through pages, watch videos, hear different opinions, and after all that you think, okay, now I know the truth. But pause. What exactly did you just find? A fact, a perspective, a feeling, or just the version that sounded the most convincing? Everyone says they want the truth, but no one tells you what truth actually is. Is it what happened? Is it what people believe? Is it what can be proven? Because those are not the same thing, and the cracks start showing the moment you try to pin truth down. Start simple. A kid breaks a window. The parent says, "Tell me the truth." The kid says, "I didn't mean to." The parent says, "That's not the truth. The truth is that you broke it." But both are technically true. One is about intention, the other is about result. So already two versions, same event. Which one is the real truth? Now scale that up. Witnesses see a car accident. One says the light was red. Another says it was green. One saw the car coming fast. Another says it was slow. You put them under oath. You get conflicting stories, all honest, all different. So where is truth now? Let's try science. Truth in science is often described as what can be measured and repeated. You test a theory, you replicate it. If it holds up, it's considered true. But science has a history of changing its mind. People once thought the Earth was the center of the universe. That bloodletting healed disease, that light traveled through something called ether. These weren't lies. They were the best models available at the time, accepted by the smartest people, and now they're considered false. So truth in science isn't a final answer. It's a current best guess. It's what hasn't been disproven yet. And that means, even in the most rigorous field, truth can expire. What about logic? Can something be true just because it follows from the rules? Yes, but only within the rules. In math, for example, 2 plus 2 equals 4 is true, but only because we define the numbers and operations that way. Change the base system and the result changes. In base 3, 2 plus 2 equals 11. Still correct in a different system. So logical truth is not absolute, it's local, it's true within a framework. Now go to the courtroom. Two lawyers, one case. Both present their version of the truth. Both use evidence, witnesses, timelines, but only one wins. Does that mean the other side's truth didn't exist, or just that it wasn't persuasive enough? Legal truth depends on what can be proven, not necessarily what happened. If no one saw it, no camera caught it, no document recorded it, the system says, not true, even if it was. What about personal truth? I feel like no one cares about me. Is that true? Maybe not objectively. Maybe many people care, but if that's what someone feels, then it is their truth. It shapes their actions, their mood, their choices, and you can't argue them out of it with data, because personal truth isn't about facts, it's about experience. So now you've got layers: factual truth, logical truth, legal truth, personal truth, scientific truth, and each one plays by different rules. So when people say, "I just want the truth," what kind are they asking for? Even in media, truth is filtered through headlines, through algorithms, through tone. The same event, war, protest, scandal, can look like a tragedy, a victory, or a distraction, depending on who tells it. And once it's wrapped in emotion, in music, in opinion, it becomes almost impossible to untangle what actually happened. That's why people now say things like "my truth" and "your truth," because it feels like everyone lives in their own version, and in a world full of information, the hardest thing isn't finding data, it's deciding which data counts. And here's where it gets even harder: memory. Your own brain can betray you. You misremember details. Your past changes each time you recall it. Entire events get rewritten based on emotion. Two siblings can remember the same childhood completely differently, and both can pass lie detector tests, because they're not lying. Their minds just chose different angles. So truth isn't just slippery, it's unstable, even inside your own head. Now let's talk belief. If you believe something strongly, it starts to feel like truth. It feels solid, even if it's not proven. And the more it's repeated, the more real it becomes. That's called the illusory truth effect. Hearing something again and again makes you more likely to believe it, even if it's false. So repetition can create the illusion of truth, not because it's accurate, but because it's familiar. So how do you know what's actually true? You might say, well, truth is what matches reality. But that raises a deeper question. How do you access reality? Through your senses, they can be fooled. Through instruments, they have limits. Through logic, we've seen that logic breaks. Through Kant's. And thus, that changes. Through faith, that varies. Every method has blind spots. And then there's the problem of motivation. Sometimes people don't want the truth. They want comfort or control or a simple answer. Sometimes truth is inconvenient, and when it is, people bury it, deny it, replace it with something easier to accept. That's why societies build myths, why history gets rewritten, why uncomfortable facts are erased or ignored, because truth isn't always welcome. It can hurt, it can destabilize, it can demand change. And maybe that's the most important part. Truth has power, because real truth forces you to act. If you know something is true and you ignore it, there's a cost. Emotionally, ethically, existentially. That's why people fight over truth, why it matters, because truth, when it's real, isn't just a fact, it's a responsibility. So what is truth? Is it the most consistent story, the most repeatable result, the most widely accepted view, the most deeply felt belief? Or is it something else, something always just out of reach, shifting with time, perspective, and language? Maybe truth isn't a destination. Maybe it's a direction, something you aim for, refine, get closer to, but never fully own. Because if memories change, if facts expire, if logic depends on structure, if science evolves, if belief distorts, if reality itself bends with perspective, then maybe the only honest answer to what is truth is this: truth is not what you hold, it's what you search for. You're sure it happened, you remember the words, the look, the feeling, it's burned into your mind, no way you're wrong. But then someone else remembers it completely differently. They swear it didn't happen like that, and now you're both certain and completely in conflict. So who's right? If memory is how we know the past, what happens when memory lies? We treat memory like a hard drive. You store things, you pull them up, they play back the same every time. But that's not how it works. Memory is not a file, it's a reconstruction. Every time you remember something, you recreate it, piece by piece, detail by detail, from fragments. And every time you do that, it changes a little. Some things sharpen, some things blur, and some things shift entirely. Think of a childhood birthday. Try to picture the room, the cake, the voices, you see it, clear. But how much of that is the real event and how much is the photos you've seen, the stories you were told, the emotions you feel now projected onto the past? Memory isn't just a record, it's a story your brain writes, and edits, and rewrites. Let's go deeper. There's a thing called the Mandela effect, named after people who remembered Nelson Mandela dying in prison even though he didn't. These weren't vague memories. They were detailed, specific, and wrong. Or take the Berenstain Bears, a children's book series. Thousands of people remember it as Berenstein, with an E, but it's not, it never was. Still, people swear they remember it that way, with full confidence. So where did the false memory come from? Psychologists explain it through pattern recognition. Your brain tries to make sense of information using familiar shapes, sounds, and categories. Berenstein sounds like other names you know, so your brain files it that way. It's not a glitch, it's a feature. Your brain doesn't aim for accuracy, it aims for coherence. It fills gaps, smooths edges, adds logic, even when the truth is different. Now think about eyewitness testimony. In courtrooms, it used to be gold. I saw it happen. But today we know better. Memory can be planted, shifted, shaped by questions. There's a famous study by Elizabeth Loftus. She showed people footage of a car crash and asked, how fast were the cars going when they hit? Others heard, when they smashed. The second group reported higher speeds, more broken glass, even though there was none. One word changed their memory, not their perception, their memory. That's how fragile it is. Even traumatic memories, the ones we think are burned in the deepest, can warp. PTSD survivors sometimes recall things out of order, or with missing pieces, or with added details, and none of it is intentional. The brain doesn't record trauma like a video. It records fear, stress, fragments. It tries to protect, not preserve. And memory isn't stored in one place. It's a network, visual pieces in one region, sounds in another, smells somewhere else, emotions layered on top. To remember something, your brain reactivates all those spots, reassembles them. And just like re-downloading a file over and over, sometimes things get corrupted. There's also memory decay. The longer it's been since something happened, the more likely it is to degrade. You forget names, faces, timelines, that's expected. But the twist is you don't notice the decay. Your brain fills the missing parts without telling you. You think you remember, but what you remember is a reconstruction based on a degraded source. And it gets stranger. You can form memories of things that never happened, through dreams, through stories, through suggestion. You can remember being lost in a mall as a kid, even if it never happened. If someone tells you the story enough times, the emotion feels real. The picture in your mind feels real, but it's fiction. That's called a false memory, and it's terrifyingly easy to implant. Then there's the role of emotion. Memories with strong emotion, joy, fear, anger, feel more vivid, more real, but that doesn't mean they're accurate. Emotion makes a memory stick, but it also distorts. It amplifies certain pieces, hides others. You remember the slap, but not the context, the betrayal, but not your own actions. The pain sharpens one detail and blurs the rest. So what does that mean for who you are? Because memory isn't just about events, it's about identity. You remember being a child, a teenager, you remember mistakes, triumphs, moments of change. That's how you build a sense of self. I am this person because these things happened. But if memory is flawed, then identity is built on sand. And it goes further. You can't predict the future without memory. Every decision you make, what to trust, what to avoid, who to love, is based on what you remember. If your memory shifts, your decisions shift, your future shifts. You don't just lose the past, you lose direction. So what is memory? It's not a recording, it's a painting, redo. Each time you look at it, slightly different, a little darker, a little brighter, maybe the frame changed, maybe the background shifted, but you don't notice, you still say, that's how it happened. And that's the trap. You believe memory is truth. You say, I know what I saw. I remember what you said. You promised. But memory isn't the truth. It's your brain's version of truth, customized, rewritten, adapted to your needs, your feelings, your expectations. If memory can be edited, erased, and even invented, how do you know which parts of your past ever really happened? You're thinking right now, you're aware of these words, you know you exist, and that feeling, that internal awareness, is what we call consciousness. It's not a sound, not a shape, not a thought. It's the thing that knows you're having a thought. You can't see it, you can't touch it, but it's the most intimate thing you have. Without it, there's nothing. Without consciousness, there's no world, no self, no experience. But here's the strange part, no one knows what it actually is. Science can track brain activity. It can show you which part of your brain lights up when you feel happy or sad or scared. But it can't explain why there's a you that feels those things. Because a brain is just a machine, neurons firing, chemicals moving. So why does it feel like something to be you? That's the mystery. That's what philosophers call the hard problem of consciousness. How do physical processes produce subjective experience? You can describe the brain in detail. You can simulate it. But you still can't point to the exact moment where atoms become awareness. Take a computer, it processes inputs, it reacts, it even learns. But does it know it's learning? Does it feel joy when it wins a game? Does it feel fear when it fails? Probably not. Because computation isn't consciousness, it's function, not feeling. And yet your brain is also just a machine. So what makes the difference? Where does the self come from? Here, that's where it gets trickier. Split brain experiments in the 1960s cut the connection between the two hemispheres of the brain in certain patients. What happened shocked everyone. It was like the person now had two centers of consciousness. One side could speak, the other couldn't, but it could act. Each side had access to different information. One could know things the other didn't. One could even contradict the other. Meaning the single self, we think we might just be an illusion held together by communication between brain parts. Break that and you get two selves. So maybe your consciousness isn't unified. Maybe it's just the strongest story your brain is telling right now. And then comes anesthesia. You go into surgery, they inject something, count backwards from 10. And then nothing, total blackout, not sleep, not a dream, just nothing. But here's the thing, your heart keeps beating. Your body stays alive, your brain keeps working, but you disappear. Consciousness goes offline and no one knows how, or why it comes back, or where it goes. We know how to lose consciousness, but we don't know what it is we're losing. And if something so basic, so essential can vanish and return without explanation, what does that say about what it really is? Some scientists think consciousness might be like a spotlight. It only focuses on a small part of your mind at any moment. Your subconscious is huge, full of thoughts, feelings, memories, but only a few make it into the light. And that spotlight, it's not under your control. You don't decide what grabs your attention. You just notice that it happened. You realize you're thinking after the thought began. So who's driving? If thoughts arise before you're aware of them, are you really in control? Or are you just a passenger watching the ride? There's also a theory called Integrated Information Theory, IIT. It tries to measure consciousness in terms of how much information a system integrates. The idea is the more a system can connect and combine information, the more conscious it is. But even if that's true, it still doesn't explain the feel of being you, because quantity of information isn't the same as quality of experience. A camera sees, a thermostat responds, a phone recognizes faces, but none of them feel anything. So how do you know you're not just like them? Because you say so. Because you feel it, but what if that feeling is just another illusion, another process your brain makes up? Now think about dreams. While you're dreaming, everything feels real. You have a body, you have a world, you feel pain, emotion, movement, but none of it exists. Your eyes are closed, your body isn't moving, and still the experience is real to you. So if your brain can fabricate entire worlds while unconscious, what makes you so sure this world is real? What if your waking life is just another layer of the dream when you haven't realized yet? Neuroscientists also point out that consciousness is slow. You react before you're aware. Studies show your brain makes decisions before you consciously decide. Your hand pulls away from a hot stove before you even feel the pain. You're late to your own experience, always slightly behind. So again, who's in control? And if you're not the first one to know what you're doing, are you really the one who's choosing? Then there's the mirror test. It's a simple experiment. Put a dot on an animal's forehead and see if it recognizes the dot in the mirror. Some animals do, like elephants, dolphins, apes, and even magpies. Others don't. The test is supposed to show whether the animal has a sense of self, an I, but what if it just shows whether they understand mirrors? What if consciousness isn't about reflection but about presence? And if we define it based on behavior, we might miss it entirely in creatures who are conscious but can't communicate it. What about babies? Are they conscious at birth? What about people in comas or advanced AI? If someone or something acts conscious but can't tell us, do we assume they are or not? And what if consciousness comes in degrees, not on or off, but a spectrum, like light, like heat? What if rocks have 0, bacteria have 1, insects 10, dogs 100, humans 1,000? Is your dog conscious? Is a mouse? Is an ant? And if yes, where does it stop? Because if everything has some amount of consciousness, then maybe it's not rare, maybe it's not special, maybe it's fundamental. But then again, if everything has consciousness, then what's the point of using the word? Consciousness becomes everything and nothing. And here comes the deepest cut. If your entire experience of the world depends on your consciousness, but no one knows what consciousness is, then what is your world made of? Not matter, not energy, but awareness. You don't experience the world directly. You experience your experience of it. So what's more real, the thing you see or the seeing? And if everything you know is filtered through consciousness, then how do you know what's real and what's just a hallucination you've been living inside your whole life? Because if consciousness is the lens through which you see the world, but the lens has no clear shape, no clear edges, and no explanation for how it works, then how do you know you're even awake right now? Try to imagine nothing, not darkness, not silence, not emptiness, nothing, no space, no time, no objects, no thoughts, just non-existence. It sounds simple. But the more you try to picture it, the more your brain fills it with something, a blank screen, a black void, a silent room, but those aren't nothing, they're just really empty somethings. Because your mind isn't built to grasp true nothing. It always reaches for a form, a frame, a background, even when that background is supposed to be gone. So what is nothing, really? Is it even possible? Or is it just the word we use when we hit the edge of what we can describe? Start with space. You look into outer space and say it's empty. But it's not. Even in a vacuum, there's quantum activity, virtual particles popping in and out of existence, fluctuations, fields, radiation. Space isn't nothing. It has dimensions, it has properties, it has stuff, just very little. And even the vacuum isn't truly empty, it's seething with energy at the smallest scales, the so-called quantum foam that underlies everything. So even the emptiest part of the universe isn't actually nothing. Okay, what about before the universe, before the Big Bang? We usually say there was nothing, but time didn't even exist then. And if there's no time, then what does before even mean? You can't have a before without a timeline. You can't have a cause without time to separate cause and effect. So the sentence before the universe there was nothing might not just be untrue, it might be meaningless. A sentence that sounds correct but refers to nothing at all. Now let's flip it. What if instead of the absence of something, nothingness is the default and something is the strange part? Think about that. Why does anything exist at all? Why is there a universe? Why is there matter, energy, space, thought? Why is there not just nothing? It's the deepest philosophical question, and no one has an answer. You can explain how things work, how particles form atoms, how stars form galaxies, but you still haven't explained why there's anything in the first place. Why not just pure absence? Even in mathematics, 0 was a late invention. The ancient Greeks avoided it. Roman numerals had no symbol for it because it was scary, abstract, a number that meant none. It didn't count things, it meant no thing. And yet without 0, modern math collapses. It's the base of the place value system. It separates negative from positive. It defines the origin. but the concept itself still feels strange. How do you count nothing? How can something represent the absence of all things? And then there's the paradox. If nothing exists, then it's something, right? If you say there is nothing, you're describing a condition which is itself something. You've already filled the void by naming it. So maybe the problem isn't with the universe. Maybe the problem is with language. Maybe our brains just aren't wired to describe nothing without turning it into something. In physics, vacuum states are never truly zero. In quantum field theory, even empty space has a ground state, the lowest possible energy it can have. So the lowest possible value is still not nothing. In fact, some theories suggest the universe itself came from a quantum fluctuation in this kind of vacuum. In other words, a blip in almost nothing created everything. But again, that's not true nothingness. That's a field, a set of rules, a physical state. You can't create something from true nothing unless nothing already has rules. And if it has rules, then it's not nothing. Now think about death. Most people imagine it as a kind of nothingness. No thought, no perception, no time. But again, that's just our way of describing a state we can't experience. Because experience itself requires something, a body, a brain, a sense of time passing. If death is the end of experience, then it's not something you can ever be aware of. And if you can't be aware of it, can you even call it a state at all? Or is it just the absence of all states? In Buddhism, there's a concept of emptiness, not as a void, but as a lack of inherent existence. That things don't exist independently, but only in relation to other things. So nothingness isn't a black hole, it's the realization that what we call things are just patterns, processes, temporary arrangements, and when they disappear, the illusion of something disappears too. But here's the kicker: in some theories of cosmology, nothing may not even be possible. There might always be a vacuum, a field, a set of laws, a baseline existence. So even if you took away all the galaxies, all the atoms, all the energy, something would remain, and that something is what allows everything else to exist. So maybe nothing is just an idea, a word we made up to point at an edge we can't cross, a limit we can't look beyond. And if that's true, if there never was nothing, if space is never empty, if vacuums still vibrate, if before the universe makes no sense, if zero took centuries to define, if language collapses trying to describe absence, then maybe the real mystery is, why is there something instead of nothing? But whether nothing ever existed at all. Space feels like the background, the stage, the nothing that holds the something. You move through it, you point at it, you think you understand it. But the more you look, the more space stops being empty and starts being weird. It bends, it stretches, it grows, it curves. So maybe space isn't the passive backdrop you thought it was, maybe it's the main character. Start with something obvious. You stand in a room, you say there's nothing in the corner, but that nothing has dimensions. You can measure it, it has width, height, depth. If you walk into that corner, you take up its space. So even empty space has properties. It isn't zero, it's something. Now scale up, look at the solar system. You think the planets are floating in a void, but space isn't neutral. Einstein's general relativity showed that mass bends space. Like a bowling ball on a trampoline, that's why the Earth orbits the Sun. Not because of invisible forces pulling in straight lines, but because space itself is curved. Earth is rolling along that curve, so space doesn't just contain motion, it creates it. Go further, in 1917, Einstein added something to his equations, the cosmological constant, a kind of energy built into space itself. He called it his biggest mistake, but today we call it dark energy, the force that's making the universe expand faster and faster. So space isn't just a container, it has energy, it can change, and that change controls how galaxies move. Empty space controls the fate of the universe. Let's zoom in. At the quantum level, space is never still. Virtual particles pop in and out of existence. Tiny fluctuations jitter constantly. Even a perfect vacuum isn't quiet, it fizzes with potential. That's why there's something called zero-point energy, the lowest possible energy level, even when everything else is removed. So space can't be emptied, not completely, because the vacuum itself isn't zero. Now let's flip it. If space is something, can it have a smallest part, a pixel? In quantum gravity, there's something called the Planck length, about 1.6 times 1035 meters. Smaller than that, and space stops behaving like space. It becomes meaningless. You can't zoom in more, you hit a floor, so space might not be infinitely divisible. You can't slice it forever. There's a bottom, a limit. Space has granularity, like matter, like energy, like everything else. And then there's entanglement. Two particles on opposite sides of the universe can affect each other instantly. Faster than light, but nothing's traveling, there's no signal, which means space doesn't separate them the way you thought. The distance doesn't matter, the information isn't limited by location, so space doesn't act like space, at least not at the quantum level. Now think about black holes. You compress matter into a single point, a singularity, infinite density and zero volume. But what is that point? Is it in space or does it create space? Some physicists say space itself ends at the singularity, that it's not a place in space, it's the edge of space, the place where geometry stops working. So space isn't infinite, it has edges, limits, holes. Let's flip again. What if space isn't even real? Some theories, like the holographic principle, say that everything happening in a volume of space is actually encoded on its surface. Like a hologram, a 3D illusion projected from a 2D boundary. So space, the whole thing you move through, might be a trick, a construct, just a way of organizing information. And then there's something called emergent space. The idea that space doesn't exist at the most fundamental level, that it's not a background but a product, a consequence. It only appears once enough particles, fields, or information interact in the right way. In other words, no particles, no fields, no space. It's not the stage, it's the result. Now ask something simple. If space is expanding, what's it expanding into? The answer is uncomfortable. Nothing. Space doesn't need something outside it. It grows from within. Like stretching a balloon, the surface expands, but there's no extra surface outside it. The balloon creates its own room. The universe is doing the same. It's not expanding into something, it's just expanding. And here's where your brain starts to shake. If you remove all matter, all light, all energy, does space still exist? If you remove all observers, all frames of reference, all coordinates, what's left? Is space a thing, or just a relationship between things? Can you have space without objects, without distance, without time? So if space bends and stretches, if it has energy, if it seethes with quantum activity, if it can end in black holes, if it might be a hologram, if it might not even exist at the deepest level, then what is space really? A dimension, a field, background, or just the word we use for something we can't stand not to have between things? You think you know where you are. You're sitting in a chair, in a room, in a house, on a street, on a planet. But pause for a second and ask, where exactly are you? Not approximately, not relatively, exactly. Can you point to a fixed spot in the universe and say, here, this is my absolute position? You can't, because there's no such thing, not in physics, not in reality. Start simple. You say your phone is on the table, but that only makes sense because of the table. Remove the table and suddenly your phone is on anything. It's just somewhere. But where is somewhere if there's no reference point? That's the first clue. Position is always relative. It only exists in relation to something else. Now zoom out. Earth is orbiting the sun. The sun is moving around the center of the Milky Way. The Milky Way is drifting through space in a local group of galaxies, and that cluster is moving too. So even if you sit perfectly still, you're not still. You're moving at hundreds of kilometers per second, constantly. So your position, whatever it is always changing. In classical physics, this wasn't a problem. You could just pick a frame of reference, call Earth your 0 point, measure everything from there. But then Einstein came along, and he said there is no universal frame, no fixed backdrop. Motion is relative, time is relative, space is relative, and that means position is relative too. Let's say you're on a train, you drop a ball, it lands at your feet. From your view, the ball just goes down. But someone standing outside the train sees the ball travel in an arc because the train is moving. Who's right? Both of you, each from your own frame. There's no true position of the ball, just positions relative to observers. Now enter quantum mechanics, where things get even more slippery. At the subatomic level, position isn't even definite. You can't know a particle's exact position and its exact momentum at the same time. That's the Heisenberg uncertainty principle. The more precisely you know one, the less you know the other, which means position itself becomes fuzzy, not just unknown, undefined. Take the famous double-slit experiment. Fire a single particle at a barrier with 2 slits. It passes through and creates an interference pattern like a wave, but waves aren't localized, they're spread out. So until you measure the particle, it isn't in one place. It's in a probability cloud. It has possible positions, not actual ones. Only when you observe it does it choose where to be. Now apply this to you. You, made of atoms, made of particles, your position feels fixed. But at the deepest level, the particles that make you don't have fixed positions. They're constantly shifting, tunneling, interacting. Their exact locations are unknowable, which means your position isn't a point, it's a blur. Let's go deeper. What if space itself is quantized? Some theories in quantum gravity suggest that there's a minimum unit of distance, a pixel of space. Smaller than that, and position becomes meaningless. There's no more between the points. So the very concept of being somewhere has a lower limit. And here's another crack: the GPS system. Your phone tells you where you are, but how? It uses satellites, and those satellites rely on synchronized atomic clocks, but the clocks have to be adjusted constantly because of time dilation. Gravity and velocity affect the passage of time, and that means your position, measured in real time, is distorted by the curvature of space-time. You correct it with relativity. Without it, your phone would tell you you're hundreds of meters away from where you actually are. So even everyday position depends on relativistic math. Now think about this: if the universe is expanding, then every point in space is moving away from every other point. That means your position in the universe is shifting, not because you're moving, but because space is moving. So what does it mean to be somewhere if the very fabric of somewhere is stretching? And finally, if nothing in the universe is absolutely still, and all positions are relative, and particles don't have definite locations, and measurements depend on the observer, then where are you really? Maybe position is just a temporary agreement, a label we give to motion when we want to pretend we're standing still. You say two things are far apart or close. You measure them in meters, kilometers, miles. It feels simple. Distance is just the space between 2 points, but what exactly are those points, and what happens to the distance between them when space itself changes? Start with something basic. You stretch out a tape measure between two walls. It says 3 meters, easy, but now you put one wall on a moving train. Suddenly the measurement shifts depending on who's watching. If you're on the train, it's still 3 meters, but if you're standing outside, the wall is moving. And if it's moving fast enough, the space between them contracts. That's not imagination. That's Einstein's special relativity. When objects move close to the speed of light, distances shrink. It's called length contraction, and it means distance is not fixed. It depends on speed. Now flip it, go near something massive like a planet. According to general relativity, mass curves space. The stronger the gravity, the more space bends. So if you try to measure a straight line near Earth, it's not actually straight. Space itself is distorted. And that means even if your ruler says 1 meter, the real spatial separation is curved. Distance bends with gravity. Now zoom into the quantum world. The smaller you go, the weirder it gets. Particles don't have fixed positions. They exist in probability clouds. So how do you measure the distance between two things if those things don't even have defined locations? You can only talk about the likelihood of where they might be. Distance becomes statistical, fuzzy, not an exact value, but a range of possibilities. Then comes the Planck length, about 1.6 times 10^3 meters. According to some theories, it's the smallest meaningful unit of space. Below that, space itself loses definition. It's not that the distance is tiny, it's that distance doesn't make sense anymore. You can't go half a Planck length. There's no in-between. Space isn't continuous. It's pixelated. So what does it mean to move if there's a limit to how finely you can divide space? How do you define between here and there if there's a smallest step you can take? That's not just theoretical. Some approaches to quantum gravity, like loop quantum gravity, actually build on this. They say space is quantized. That distance comes in discrete chunks, not smooth, not continuous, but step by step. Let's go cosmic now. The universe is expanding. Galaxies are moving away from each other, not because they're flying through space, but because space itself is stretching. So imagine this: light from a distant galaxy takes billions of years to reach you. During that time, space expands, which means the galaxy is now much farther away than it was when the light left. The distance depends on how you measure it now or then, or averaged over time. That's why astronomers talk about things like comoving distance and light travel distance, because distance isn't one number anymore. It's a question of which distance you mean. Now think about GPS again. It measures the distance between your phone and a satellite using the time it takes for a signal to travel. But because the satellite is farther from Earth's gravity, time ticks differently. That tiny time difference means huge errors in position unless you adjust for relativity. So even something as everyday as walking directions depends on correcting for space and time bending. And now imagine this: you're dreaming. In your dream, you walk across a city. It takes time, you feel the distance. But then you wake up and realize you never moved. Nothing changed. Distance was an illusion created by your brain, just sensations, just sequences. So here's the question: if your mind can simulate distance, how do you know this one is real? Even philosophically, distance gets slippery. Is emotional distance the same as physical? You can be in the same room as someone and feel a million miles apart, or be continents away and feel them close. Your brain maps nearness in feelings, not just space. So distance isn't just physics, it's perception, it's context. So if the space between things bends with speed, if gravity curves distance itself if at quantum scales, location is a blur if below a certain size, space stops making sense if the universe stretches, while you measure if your GPS needs to fix time to measure space, if your dreams can create false distances, then maybe distance isn't what you think. Maybe distance is just a story we tell to feel like things are separate. You see a car drive by, a bird fly, a ball roll across the floor, and you say it's moving seems simple. Motion is just change in position over time. But stop for a second, change relative to what? Because motion isn't something that exists on its own. Motion is always compared to something else, and that opens a door most people never look through. Start with the classic example. You're on a train, you toss a ball straight up. It goes up, comes back down, lands in your hand, looks normal. But someone standing outside the train sees the ball moving in a curve forward and up then down. Same ball, same throw, two different motions. So which one is real? Trick question, both are, because motion depends entirely on your frame of reference. Now imagine floating in deep space. No planets, no stars, just you and another spaceship. You see it moving, but are you still, or is it, or are both moving? There's no way to tell without something else to compare to, and that's the key. Motion isn't a property, it's a relationship. It exists only between objects. Remove the reference point and motion becomes meaningless. Now let's go deeper. In Newtonian physics, motion makes sense. Forces cause acceleration, everything follows rules. But then Einstein came along. Special relativity said, when you move faster, time slows down, mass increases, length contracts. Motion doesn't just change your position, it warps your experience of reality. And again, it's all relative. There's no absolute still, no perfect at rest. Everything is in motion compared to something else. Now zoom into the quantum world. It gets worse. At the particle level, objects don't have defined positions or velocities. They have probabilities. You can't say where something is and how fast it's moving at the same time. That's the Heisenberg uncertainty principle. The more precisely you know one, the less you know the other. So motion, the change in position over time, becomes blurry, vague, not wrong, just undefined. Now flip it again. Think about being on a treadmill. You're running, your legs are working, your muscles are pumping. But are you moving? Relative to the room, no. Relative to the belt, yes. So motion isn't just what your body does. It's what changes between you and something else. You can run and go nowhere. You can sit still and spin with the earth at 1,000 miles per hour. Motion is real and imaginary. Let's go even stranger. In physics, there's something called Mach's principle. It suggests that the motion of an object can only be defined in relation to the mass of the entire universe. Meaning, a spinning ball knows it's spinning because of the rest of the cosmos. If nothing else existed, it couldn't tell if it was spinning or still. So even basic rotation needs a reference, not just nearby, but cosmic. Now try this. You're in a car at a red light. Another car beside you starts moving forward. You feel like you're moving backward even though you're still. Your eyes see change, your body doesn't, and your brain gets confused. That's called vection, the illusion of motion, and it proves that your mind can feel movement even when it's not there. So if motion can be faked, how do you know when it's real? Even more, motion is never continuous. At the tiniest scales, some physicists believe space and time are quantized. That means you don't smoothly glide from point A to point B, you jump, discrete ticks, like pixels in space or frames in time. So that smooth motion you feel, it could just be an illusion of rapid jumps, like a movie playing fast enough that your brain sees it as one flowing action. And here's one more crack. In quantum field theory, particles don't move through space like tiny balls. They're excitations in a field, meaning an electron isn't a thing flying through space. It's a ripple, a vibration. So when we say it's moving, we're just saying the ripple shifted. But the field itself never goes anywhere. Motion becomes a change in pattern, not in position. So if motion depends on your point of view, if you can't tell you're moving without something to compare to, if quantum physics makes position and velocity uncertain, if relativity warps motion depending on your speed, if even spinning depends on the rest of the universe, if illusions can trick your brain into feeling motion, if particles don't move but ripple in place, then what is motion really? Maybe it's not something things do. Maybe it's just how we describe the space between stillness and change. You're driving down the highway, the speedometer says 100. You feel the wind, the vibration, the hum of motion. Simple, you're going fast, but fast compared to what? Because speed, like motion, only makes sense when there's something else to measure it against. And the second you question what that something is, the idea of speed starts to fall apart. Let's start easy. You're sitting on a plane, you're buckled in, you sip your drink, you feel like you're still. But you're moving at over 900 kilometers per hour relative to the ground. Now look out the window, clouds drift by slowly. The earth spins beneath you. The plane moves, you move. But inside, everything feels calm. Because relative to the plane, you're not moving at all. Now imagine two cars, both are going 60. One is driving north, the other south. If you're standing still, you'd say both are going 60. But if you're in the first car and the second one passes you, it looks like it's going 120. Because from your frame of reference, that's the relative speed. So again, speed is never absolute. It's always speed compared to x. Even when we say something moves fast, we mean fast compared to what we expected. A snail on a table seems slow. A cheetah chasing prey seems fast. But to a planet, both are practically frozen. The Earth spins at about 1,600 km/h at the equator. It orbits the Sun at about 107,000 km/h, and the Sun orbits the center of the galaxy at 828,000 km/h. So you sitting still are actually moving at insane speeds through the universe. You just don't feel it, because everything around you is moving too. Then comes light, the universal speed limit. 299,792 kilometers per second. No object with mass can go faster than that. Why? Because the faster you go, the more energy it takes. And to reach the speed of light, you'd need infinite energy, not just a lot, literally infinite. And that's not possible, at least not with our current physics. But light does move that fast, always, no matter what. If you shine a flashlight while standing still or while flying on a spaceship, the light beam moves away from you at the exact same speed. That's what Einstein's special relativity showed, and because of that, everything else has to adjust. Time slows down, mass increases, length contracts, just to keep the speed of light constant. That's why speed affects time. Astronauts in orbit move so fast that time slows down for them. GPS satellites have to correct for this every day. If they didn't, your phone would show your location several kilometers off. Speed, something that feels simple, literally bends the flow of time. Let's make it more everyday. You're running on a treadmill, the belt moves, you move, but relative to the room, you're standing still. So are you going fast or not? The answer depends entirely on the frame you choose. There is no true speed, only speed relative to something else. In water, speed works differently. Try walking through a swimming pool. It's harder. Why? Because water resists motion. Same with air. That's why planes have airspeed and ground speed. A plane might fly at 800 km/h through the air, but if there's a strong headwind, its ground speed, how fast it moves relative to Earth, could be 700 or less. The air it moves through matters, just like you in the pool. Now shrink things down. At the quantum level, speed gets fuzzy. You can't even say exactly how fast something is moving and exactly where it is. The more precisely you measure one, the less you know the other. That's Heisenberg's uncertainty principle again. So speed, defined as distance over time, becomes unclear. You can't even agree on the inputs. And then comes light again. Photons, particles of light, always move at the speed of light, but from their perspective, they experience no time. A photon emitted from a distant star a billion years ago, and one that hits your eye now to the photon, those two moments are the same. There was no time in between, because at light speed, time stops. So for light, speed doesn't mean movement through time, it means skipping time entirely. Even sound depends on speed. Sound travels faster through steel than through air, faster through warm air than cold. Why? Because molecules move more in warm air. They transmit vibrations faster. So the speed of sound isn't one thing. It changes depending on medium, temperature, pressure. Everything affects it. So what is speed really? Is it just a number, a measure, a feeling? If your speed depends on what you compare to. If you can sit still and move 1,000,000 kilometers per hour. If speed bends time and mass. If light breaks all your expectations. If quantum physics says you can't know both speed and position. If even in sound and water, speed depends on medium. Then maybe speed isn't just about how fast you go. Maybe speed is just the illusion that anything is stable, when everything is constantly shifting depending on your point of view. You press the gas pedal, the car doesn't just move, it pushes you back into your seat. That push, that's acceleration, not speed. Speed is how fast you're going. Acceleration is how fast that speed is changing, and that's a completely different story. Imagine standing on a train that starts to move, slowly at first, then faster. The moment you feel that pull, that lean, that shift in your balance, you're not feeling speed, you're feeling acceleration, because acceleration is what the body notices, not movement itself, but changes in movement. And here's what makes it weird. You could be flying at 900 kilometers per hour in a plane and feel nothing, smooth, steady, like you're sitting still. But if that plane turns suddenly, drops, or climbs, even slightly, you feel it instantly. That jolt in your stomach, acceleration. Your inner ear detects it before your brain even thinks about it. And physics takes it further. Acceleration is a vector, it has magnitude and direction, which means it doesn't just tell you how much you're speeding up, but also which way you're changing. So slowing down, that's negative acceleration called deceleration. Turning, that's lateral acceleration. Spinning, that's angular acceleration. It's all part of the same idea, your motion is changing somehow. Now think about gravity, drop a ball. It doesn't just fall, it accelerates, faster and faster until it hits the ground. On Earth, that acceleration is about 9.8 meters per second squared. That means every second it falls, it's going 9.8 ms faster than the second before. And you feel that too every time you jump, every time you trip, every time you ride a roller coaster. Gravity is acceleration. Not a force pulling, but space itself changing the motion of objects. In Einstein's general relativity, gravity isn't even a force the way Newton imagined it. It's acceleration caused by the curvature of spacetime. Imagine standing in an elevator that suddenly drops. You feel weightless, not because gravity disappeared, but because you're accelerating downward at the same rate as everything around you. That's what Einstein called the equivalence principle. You can't tell the difference between gravity and acceleration unless you look outside the system. And astronauts feel this too. In orbit, they're not floating because there's no gravity. They're falling, constantly, but they're moving sideways fast enough that they keep missing the Earth. It's free fall, endless fall, and because everything around them is falling too, they feel no acceleration. No push, no pull, just weightlessness. But if the engines fire, if their velocity changes, then acceleration returns. Even your car knows this. Step on the brake, you lurch forward. Step on the gas, you're pushed back. The faster the change, the more force you feel. That's Newton's second law. Force equals mass times acceleration, not speed, acceleration. That's the thing that matters. Force doesn't care how fast you're going, it cares how fast your speed is changing. And this matters in collisions. When you crash, it's not your speed that hurts you, it's how quickly you stop. A sudden deceleration, going from 100 to 0 in a split second, that's what does the damage. That's why airbags exist, not to stop you, but to spread out the deceleration, to slow you down just enough over time so you don't break. Even in space launches, it's acceleration that's carefully managed. Rockets build speed gradually, not because engines can't go faster, but because the human body can't handle too much acceleration at once. Pilots and astronauts train in centrifuges to withstand g-forces, a measure of acceleration relative to gravity. 1g is what you feel on Earth. 3g feels like triple your body weight pressing you into the seat. At 9g, most people black out, not from speed. From acceleration. And here's the strange part, acceleration is absolute, speed is relative. You can debate how fast you're going depending on your frame of reference, but if you're accelerating, there's no question. It shows up in your body, your instruments, your math. That's why acceleration is more real than speed. It's measurable in any frame, and it changes everything. Even in psychology, we feel this. A life changing too fast, that's emotional acceleration, going from calm to panic or peace to excitement in seconds. The brain processes not just where you are, but how quickly you got there. A job promotion feels different when it takes 10 years versus 10 days, because it's not just the destination, it's the curve. So if you can move fast and feel nothing, if a sudden stop causes more damage than speed itself, if gravity is indistinguishable from acceleration, if your weight changes depending on how fast you're changing speed, if the universe bends motion to create acceleration, if time and space themselves curve under it, then maybe acceleration isn't just a change in motion. Maybe it's the silent force behind everything that feels. You lift a rock, it's heavy. You push a shopping cart, it rolls. You try to move a truck and nothing happens. That difference, that's mass, not weight, not size. Mass, and it's one of the most misunderstood concepts in physics. Mass is the measure of how much matter something contains, but more than that, it's a measure of how much something resists change. The more mass something has, the harder it is to move, to stop, to turn. That's what Newton called inertia. Mass is resistance to motion. It's not about being big, it's about being stubborn. Picture a bowling ball and a balloon. Same size, maybe, but one has way more mass. Try pushing both. the balloon flies, the bowling ball barely moves, that's mass. It doesn't care about shape or volume, only about how much something pushes back when you try to move it. And here's what gets strange: weight and mass aren't the same. Weight is how much gravity pulls on you. Mass is how much matter you have. On the moon, gravity is weaker. You'd weigh 6 times less, but your mass exactly the same. You're still made of the same atoms. You still resist motion the same way. Your scale changes, but your body doesn't. Now take it deeper. Einstein's famous equation E equals mc squared says energy and mass are interchangeable. That means mass is energy, compressed, concentrated, locked-in energy. When you split an atom in nuclear fission, a tiny bit of mass disappears and turns into an explosion of energy. That's how the sun shines. That's how nuclear bombs work. Mass becomes light, heat, force. And the equation works both ways. Add enough energy and you can create mass. In particle accelerators, energy smashing together creates new particles. Matter from energy. The universe doesn't see a difference. Then comes the Higgs field. In 2012, scientists at CERN confirmed the existence of the Higgs boson, the particle that proves the Higgs field is real. This invisible field exists everywhere all the time. As particles move through it, they interact, and that's what gives them mass. Without the Higgs field, everything would be massless. Everything would move at the speed of light. There would be no atoms, no structures, no people, just pure energy flying around forever, so your mass. It's not built in, it's not fundamental. It's borrowed from the invisible fabric of space. Now think about momentum. A truck moving at 100 kilometers per hour has a lot of momentum. Try stopping it, you'll feel the mass. But a feather at the same speed, no threat because the mass is different. Momentum equals mass times velocity. Double the mass, double the momentum. And in collisions, mass is the deciding factor. That's why big objects cause more damage, not because they're faster, but because they carry more resistance, more force, more push. Mass also shapes gravity. The more mass something has, the more it bends space. That's what makes planets orbit stars. That's what makes black holes places where mass is so concentrated not even light escapes. But here's the twist. Black holes shrink mass into near-zero space. That tells us mass can exist without size. You can have something smaller than a marble with the mass of a mountain. And your own body, mostly empty space. If you removed all the space between your atoms, your entire body would be the size of a grain of salt, but the mass wouldn't change. Because mass doesn't come from how much space you take up, it comes from what you're made of and how that stuff interacts. Even photons, particles of light, have no rest mass. They have energy, momentum, they cause effects, but they don't resist being moved because they're always moving. They don't have mass in the traditional sense. But under certain conditions, photons can give rise to mass, again, proving that mass isn't some ancient property of things, but a dynamic result of energy and fields. This matters for you. When you sit still, you have mass. When you run, you have slightly more energy, but your mass doesn't really change. Unless you move near the speed of light, then things get weird. As your speed increases, your relativistic mass increases. Not because you're gaining weight, but because the universe resists your acceleration. It becomes harder to go faster. You never quite reach light speed because it would require infinite energy. That's how tightly mass is tied to the rules of reality. So if mass is resistance to motion, if it's not the same as weight, if it's created by an invisible field, if energy can turn into mass and mass into energy, if black holes prove mass can exist without space, if motion and speed change how mass behaves, then maybe mass isn't a simple property of stuff. Maybe it's the hidden contract between matter and the universe, saying, you can exist, but only if you pay the price in resistance. You push a door, it opens. You kick a ball, it flies. You slam the brakes, your car stops. That's force. The invisible muscle of the universe. You don't see it, you don't touch it. But everything that moves, bends, breaks, or holds together does it because of force. Force is what causes acceleration. Newton said it best, force equals mass times acceleration. That's not just a formula, that's the rule behind every movement in the universe. Push something harder, it moves faster. But if it has more mass, it resists. That's why shoving a couch is harder than sliding a chair. Same push, different mass, different result. Think of walking, every step is a force. Your foot pushes the ground and the ground pushes back. That pushback, it's called the normal force. It's why you don't fall through the floor. Because the floor is pushing up just as hard as gravity is pulling you down. Speaking of gravity, it's a force too. Not because it pulls you like a rope, but because masses bend space and objects naturally fall into those bends. You don't stick to Earth because something's yanking you down. You stick because Earth's mass curves the space under your feet. That curve creates what we call gravitational force. There are four fundamental forces in nature: gravity, which pulls masses together; electromagnetism, which attracts and repels charged particles; the strong nuclear force, which holds atomic nuclei together; and the weak nuclear force, which allows particles to decay. Every interaction, from galaxies spinning to atoms splitting, boils down to these four. When you rub your hands and feel heat, that's friction, another type of force. Friction resists motion between surfaces. It's why cars need tires, why ice is slippery, why you can't slide a sofa forever. Friction turns motion into heat, another form of energy, and that's still force at work. Now imagine throwing a ball. The harder you throw, the more force you apply, but once it leaves your hand, no more push. The only forces acting are gravity pulling it down and air resistance slowing it. That's the key. Force changes motion, but only while it's applied. No force, no change. Think about tension. Pull a rope from both ends, it tightens. That internal stretch, that's tension force, or compression, like squeezing a spring. Force isn't just about moving, it's also about resisting, holding, pressing, balancing. Even standing still, forces are everywhere. Gravity pulls you down, the floor pushes you up. Your muscles apply force to keep your balance. Inside your body, your heart pumps blood, force. Your lungs expand, force. Your cells divide, microscopic forces rearranging molecules. And on larger scales, forces move planets, create tides, shape mountains, tectonic plates collide, force. Volcanoes erupt, pressure force released. The wind against a building, force of air. Nothing big or small escapes it. But not all forces are pushes or pulls. Some are fields, like the electric field. Put a charged object nearby, and another charge feels a force, even if nothing's touching. That's action at a distance. You feel it without contact. Magnetism works the same. A magnet doesn't touch the fridge, but the force is real. It pulls, it sticks, it resists being removed. That's field force, invisible but measurable, and it's everywhere. The Earth's magnetic field protects us from solar radiation, a force field in real life. Even light exerts force. It's called radiation pressure. Shine a laser on a mirror in space, and it moves, tiny push, but still force. Even photons, massless particles, can apply pressure simply by transferring momentum. So force isn't just physical effort, it's a rule, a principle, a law. If something changes motion, force was involved. If something resists motion, force is resisting. If something maintains balance, forces are canceling each other out. And here's what's wild: force can be transformed. Chemical energy in your muscles becomes mechanical force. Electrical energy in a motor becomes torque. Heat in a gas becomes pressure. All of it different faces of the same thing, energy moving matter through force. So if every motion starts with a force, if gravity, friction, magnetism, electricity are all just different kinds of force, if force can act without contact, through fields and pressure, if even massless particles can exert force, if standing still means balancing invisible forces all around you, then force isn't just a thing you apply, it's the language of change, the reason anything moves, the invisible handshake between energy and matter. And once you see it, you realize every action, reaction, motion, or stillness is just a force waiting to happen. You wake up in the morning, you're tired, you grab coffee, now you feel alive. You eat food, now you can move, you plug in your phone, now it lights up. What changed? Energy. That's all it ever is. No matter the source, no matter the outcome, something gained energy, something lost it. That's how everything happens. Energy is the capacity to do work. That's the technical definition. But in plain terms, energy is the reason anything changes. No energy, no motion. No energy, no light. No thought, no heartbeat, no explosion, no signal, no warmth. Everything we do, everything we see, everything that exists in motion, all of it is just energy moving around. And here's the key idea: energy cannot be created or destroyed, it only changes form. This is called the law of conservation of energy. It's one of the most solid principles in all of physics. You can turn chemical energy into motion, motion into heat, heat into electricity, but you can never make energy out of nothing, and you can never delete it into nothing. You eat a banana, your body breaks it down. The chemical energy inside goes into your blood. Your muscles take that energy and turn it into movement. You walk, you talk, you think. All powered by energy that came from the sun, was stored in a fruit, and now fuels you. Same with a car. Gasoline is full of chemical energy. The engine burns it. The explosion pushes pistons. The pistons turn a crankshaft. The wheels spin, you move. But the energy didn't disappear, it just shifted from fuel to motion to heat. Even the heat your engine gives off is still part of that original energy. It just got spread out. That's the thing, energy loves to move, and every time it moves, some of it spreads. Some of it leaks into the surroundings as heat, as sound, as friction. You can never use all of it perfectly. That's why no engine is 100% efficient. Some energy always escapes. It's still there, just harder to use. Think about light. The sun shines, and light energy travels millions of kilometers to reach Earth. It hits a leaf. That leaf uses it to make sugar. You eat the plant, you get the sugar. That's energy passed from photon to plant to person. Nothing added, nothing lost, just transformed. Now take a battery, you charge it, it stores electrical energy. You use your phone, that energy becomes light on the screen, sound in the speakers, heat in your hand. Same energy, now doing different jobs. There are many types of energy. Kinetic, energy of motion; potential, stored energy like a rock at the edge of a cliff; thermal, heat energy; chemical, stored in bonds between atoms; electrical, flow of electrons; nuclear, energy stored in the nucleus of atoms; and radiant, energy carried by light. But no matter the form, it follows the same rule. It moves, it transforms, it flows, but it never vanishes. Imagine a roller coaster. At the top of the track, it's full of potential energy. As it drops, that potential becomes kinetic. It's moving fast now. At the bottom, some of that energy becomes heat from friction on the rails. Some becomes sound, but if you add it all up, total energy is still the same. It just swapped costumes. Even your thoughts are energy. Neurons in your brain fire tiny electrical signals. Those signals use ATP, a molecule charged with chemical energy. Thinking burns calories. Literally, your brain runs on energy just like your muscles. Now zoom out, think of a thunderstorm. Lightning is electrical energy from charge imbalance in the clouds. Thunder is that energy becoming sound. Rain falls, kinetic energy. It hits the ground, energy becomes heat and splash. One event, many transformations, still the same total energy. But here's the twist: while energy is never lost, usable energy is. That's where entropy comes in, the idea that systems naturally move toward disorder. Energy spreads, becomes less concentrated, harder to use. That's why your phone battery dies. The energy is still there, but not in a form you can use. It's dissipated, scattered, lost to you, not to the universe. And now the ultimate example. E equals mc2. Energy equals mass times the speed of light squared. That means mass itself is energy. Matter is just energy condensed. That's what nuclear power taps into. Splitting atoms releases huge amounts of energy because it's breaking the bonds that hold matter itself together. That's why a tiny amount of uranium can power a city, or destroy one, because the energy trapped in matter is massive, and every explosion, every fire, every breath, all trace back to energy converting from one form to another. So if every motion, every change, every life process is just energy shifting. If the sun powers plants, plants power people, and people move because of stored energy. If your phone, your thoughts, your heartbeat, your sweat, your memories are all energy at work. If the food you eat, the fuel you burn, the light you see, are all just energy-changing forms. What? Then maybe energy isn't just a number in physics. Maybe it's the real currency of existence. Not money, not time, not matter. Just energy, endlessly flowing, endlessly transforming, making everything happen. You're holding a ball in your hand, it's still, quiet, not moving, but drop it and it falls, fast, it slams into the ground, just like that energy is released. But where was that energy hiding before you let go? The ball wasn't moving, it wasn't spinning, it wasn't making noise. And yet, the moment your fingers let go, it rushed downward with force. That's potential energy, the energy of position, of setup, of possibility. You can't see it, you can't feel it, but it's there waiting. Waiting to become real, waiting to be triggered. Every stretched rubber band, every raised object, every compressed spring holds energy. Not energy in action, but energy in waiting. That's what makes it so strange. Because it's not kinetic, not movement, it's stored, dormant, ready, but not doing anything yet. Think of a bow and arrow. When the bow is relaxed, there's nothing. But when you pull the string back, tension builds, energy builds. You've done no damage, launched nothing, hurt no one. And yet, the second you release, that arrow flies. The potential became kinetic. The waiting became doing. But here's the thing, you didn't create energy, you just moved it, you stored it, then released it. And the more you stretch the string, the more potential you built up. That's the key. Potential energy depends on position, on difference, on distance. The higher you lift a ball, the more energy it stores because it has farther to fall, and because gravity will pull it harder the longer it drops. It's the same with a dam. Water behind a dam isn't moving, but it holds massive energy. Because of height, because of pressure, because of what happens when you open the gates, that water crashes down, spins turbines, generates electricity. And again, the energy wasn't new, it was potential, built from position, built from gravity. Now think of a roller coaster. When it's at the top of the hill, barely moving, it's at its highest potential. That climb was slow, deliberate. All energy was stored. The second it tips over, gravity takes over. It accelerates. Kinetic energy takes the stage. The ride begins, but the thrill was built in silence. Built in waiting, that's potential energy in action or in waiting. But here's where it gets weird. Potential energy isn't always obvious. You don't always see it. You don't always feel it. But it controls the world. Take a battery. It just sits there, cold, inert. You hold it in your hand, nothing happens. But connect it to a wire and current flows. Light turns on, music plays, electricity moves. All that energy was stored, packed inside chemically, waiting for a circuit, waiting for release. Now try this, stand at the top of a slide, just standing, not sliding, not jumping, but you feel it, that edge, that gravity, that quiet force pulling you down. You're still, but you're full of potential. One small push and everything changes. That's the invisible pressure of potential energy. It shapes every moment, every motion, every system. Let's go smaller. On the atomic level, electrons orbit atoms at different energy levels. Some are close, some are far. When an electron jumps to a higher orbit, it stores energy. When it falls back down, it releases light. Literal photons, light from stars, lasers, screens. It's all built from this microscopic potential, the energy of distance, the energy of position, and it scales up all the way to planets. Think about tides. The moon pulls Earth's oceans, but it's not a tug, it's potential and kinetic energy playing together. As the moon orbits, gravity changes water levels, high tide, low tide, slow shifts, but all powered by stored gravitational energy, by the position of two massive objects in space. And now think about fuel, gasoline, coal, even food. These are all forms of stored energy, chemical bonds holding potential, waiting to burn, to react, to digest. You don't see flames. But light a match, start an engine, eat a meal, and the potential becomes power. Everything around you is full of stored energy. Your phone, your body, your planet, but there's a hidden truth here. Potential energy is relative, it depends on reference points. A ball on a table has potential energy relative to the floor, but on a mountain it has more, same ball, different height, more energy. Why? Because the distance to fall is greater, the change is bigger, potential isn't absolute. It depends on where you are and what's below you. Even more, it depends on your system. The Earth's gravity gives potential, but take the same ball to the moon and its potential energy changes. Weaker gravity, smaller force, less potential, so it's not about the object, it's about the relationship between object and environment, between structure and field. That's what potential really is, a description of tension, of imbalance, of what could happen if something is allowed to move. But now let's talk about tension in people, not emotional tension, but the kind you feel before you're doing something big. You stand before an audience, before a job interview, before a fight. You haven't spoken yet, haven't acted yet, but everything's vibrating inside. Your heart beats faster, palms sweat, muscles tight. That's potential energy, psychological, stored, waiting. And the moment you act, it's released. It becomes movement, decision, consequence. So even in life, potential energy exists. Not in atoms, but in choices, in hesitation, in pressure, but back to physics. Here's a strange truth. Potential energy can't be measured directly. You can only measure changes in potential energy, from one state to another, from one position to another. There's no such thing as raw potential energy, only relative, only comparative, and that raises questions. Is potential energy real or just a calculation? Is it something that exists or just a tool we use to predict what will happen next? Some physicists argue it's just a bookkeeping device. We don't see it. Just infer it based on how much energy gets released. It's like a promise, a placeholder, a prediction, and yet it works every time. Drop something, it falls. Turn on a battery, power flows. Open a dam, water rushes. So even if we can't see it, it defines everything. And here's the most interesting part. Potential energy can transform from one type to another. Gravitational to kinetic, elastic to sound, chemical to thermal. It's not stuck. It adapts based on system, based on trigger, based on context. And that's why it's such a powerful idea. Because it's not just a type of energy, it's a waiting, a readiness, a system on the edge of change, and that's how the universe runs, on tension, on difference, on stored potential. The planets orbit because of gravity, potential energy turned to motion. The sun shines because of nuclear potential, atoms fusing, releasing energy. Trees grow because sunlight stores energy in sugar, chemical potential that powers life. And you move, think, feel, because cells in your body burn ATP, releasing energy that was stored in molecules created from food grown in light born in stars. All potential, all transformed, all recycled over and over. So when you look around, the world isn't static. It's full of setups, full of imbalances, full of energy waiting to move. It's a coiled spring, a stretched bow, a rock at the edge of a cliff, silent until triggered. So if every structure holds hidden energy, if every height stores force, if every cell runs on a spark that was once sunlight, then here's the real question. How much energy is sitting in silence, just waiting for a reason to move? You clean your room, everything's perfect. Bed made, floor clear, desk organized. And yet, a week later, without trying, it's a mess again. Not because someone destroyed it, not because you did anything chaotic, but because that's just what happens. That's entropy, the natural tendency of everything to move from order to disorder, from structure to mess, from neat to scattered, and it's not just a metaphor. It's one of the most fundamental laws of physics, the second law of thermodynamics. It says that in any closed system, entropy always increases, meaning disorder always wins, eventually. Imagine you open a perfume bottle in one corner of the room. The molecules don't stay there, they spread slowly, invisibly, until the whole room smells the same. That's entropy. The perfume didn't organize itself into patterns. It didn't form shapes or stay in one place. It spread, randomly, evenly, because that's what particles do. They move from concentrated to scattered. And once they scatter, they don't go back. You never smell perfume getting stronger in one corner again. That's not how the universe works. Take an ice cube, place it in a hot room. It melts, water warms, molecules spread out, energy disperses. You didn't destroy the ice. You just let entropy do its thing. Everything went from cold and compact to warm and messy. Try the reverse. Try making the water freeze itself into a cube in the same room. Won't happen. Entropy doesn't work backward. That's why a dropped glass shatters but never unshatters. Why eggs break but never reassemble. Why smoke spreads but never unspreads. Because entropy increases, always. Now look at your own life. Your body takes energy from food, it builds order, cells, muscles, thoughts, but over time disorder grows, skin wrinkles, muscles weaken, memory fades. That's not failure, that's entropy. Your body fights it for years but can't win forever. The system decays, slowly, steadily, not out of malice, just out of physics. Even the sun fights entropy. It burns hydrogen, turning it into helium. That creates light, heat, life, but each second it loses structure. It turns ordered fuel into random radiation. And one day it'll run out, burnt out, used up. That's the fate of all stars, that's the fate of all systems. Entropy wins, eventually. Now go cosmic. The entire universe started in a highly ordered state. Tiny, dense, hot, then bang, expansion, cooling, complexity, but also spreading, dispersion, growth of entropy. Today the universe is huge, cold, scattered, stars burn out, energy spreads, galaxies drift. The Big Bang was the start of a system losing order, a process that never stops. One theory even says the universe will end in heat death, a state where everything is so spread out, so even, so random that nothing more can happen. No structure, no difference, just silence. And it's not about destruction. Entropy isn't chaos, it's probability. Imagine you dump a puzzle out of the box. The pieces scatter. That's more likely than them landing perfectly assembled. Disorder has more possible configurations than order. So naturally, things drift toward disorder, because disorder has more ways to exist. Same with socks. Ever wonder why you lose one in the laundry? Because the system isn't perfect. And any imperfection, any random movement increases entropy, and once increased, it stays increased. You can fold your clothes, but unless you actively maintain order, they'll unfold, not by magic, just by entropy. It's why computers overheat, why engines wear down, why buildings crumble, because energy spreads, structures decay. Systems fall apart, unless you keep pumping energy to fight the natural flow. Every moment you clean, fix, organize, you're pushing back against entropy, but you're not reversing it, you're just spending energy to hold it off. And that energy itself creates entropy elsewhere. It's like bailing water from a sinking ship, but every bucket you toss makes a hole somewhere else. You can manage it, delay it, redirect it, but you can't stop it. Even information follows entropy. In a hard drive, bits can flip, data can corrupt, signals can degrade. The longer something exists, the more chance it has to lose integrity. That's why backups exist, why we fear data loss, because entropy creeps in, quietly, relentlessly. But here's where it gets weird. Life, in a way, is anti-entropy. Your cells build order, your brain creates structure. Society makes systems, cities rise, cultures grow, but none of that breaks the second law. Because to build local order, you must export entropy elsewhere. You eat food, that creates heat, waste. You build a city, you burn fuel, you generate pollution. You always pay a price. You don't beat entropy, you bargain with it. And the moment you stop fighting, disorder returns. Fast, think of a garden, tend it every day, it's beautiful. Stop tending, weeds grow. chaos spreads, order requires effort, disorder. Is effortless, that's the core of entropy, not destruction, but drift. The slow, inevitable movement from pattern to noise. Now let's flip it. Can you measure entropy? Yes, it's a real number. A way to count how many configurations a system can take. High entropy means many possible states. Low entropy means few. That's why a clean desk has low entropy, only one way it looks clean. A messy desk, millions of messy arrangements, so entropy is a count, a probability, a measure of options. And that's why entropy links to information. The more you know about a system, the lower its entropy, because knowledge reduces uncertainty, and uncertainty is just another word for entropy. So entropy isn't just about heat, it's about order, about knowledge, about structure. Even in black holes, entropy plays a role. They seem like perfect objects, smooth, simple, but physicists discovered that black holes have entropy based on their surface area, meaning they hide information, they destroy structure, not just matter, but order. And that challenges everything we know about physics, because if entropy erases information, then maybe the universe itself forgets. Maybe reality can lose memory. That's why entropy is so terrifying, not because it breaks things, but because it deletes patterns, slowly, inevitably, without pause. It doesn't care about beauty, about meaning, about effort. It just grows, unless you stop it, and even then only temporarily. But it's not evil, it's not a villain, it's just nature. The tendency of systems to become more probable, more flexible, less precise, and in some ways more free. Because order is constraint, rules, limits, entropy breaks those. It allows exploration, variety, possibility. A shuffled deck has more options than a sorted one. Entropy creates randomness, and randomness can spark discovery, innovation, change. So maybe entropy isn't the end. Maybe it's the reason anything new ever happens. Maybe the universe only evolves because structure falls apart and something different takes its place. But still, that quiet rule remains. Entropy increases, the clock keeps ticking, the tea keeps cooling, the stars keep fading, and one day maybe everything spreads too thin, too scattered, too even, and nothing else can happen. So if everything drifts toward disorder, if every system decays, if structure always collapses unless held, if entropy never reverses, if even the universe might die of too much balance, then ask yourself, how long can anything stay ordered before entropy finally takes it back? You flip a coin, heads or tails, 50-50, simple, but do it 10 times and get heads every single time. Suddenly it doesn't feel so simple anymore. Your brain starts screaming, something's off, but is it? Statistically, it's completely possible, not likely, but possible, and that's the trap. Probability feels intuitive until it doesn't, because what you expect to happen and what can happen are two completely different things. Let's start with the basics. Imagine you roll a die, one of those standard six-sided cubes. Each side has an equal chance, 1 out of 6. So if you roll it 6 times, you expect each number to appear once. Makes sense, feels fair. But if you roll it 1,000 times, you'll see some numbers show up more than others. One might appear 178 times, another 162. You think, wait, isn't that broken? But it's not. That is how randomness works. It doesn't mean perfect balance every time. It means possibility, not fairness. And that's the first crack, because we expect balance, we expect order, but randomness doesn't play by those rules. It doesn't care what just happened. It doesn't care what should happen next, it just happens. Now imagine this, you're watching a roulette wheel. It lands on red 5 times in a row. A crowd forms, people whisper. It has to be black now, more red. Okay, now it's definitely black. But statistically, the wheel doesn't know its own history. Each spin is independent. Red 10 times in a row doesn't make black any more likely on the 11th. But our brains can't accept that. We feel the imbalance. We need the balance, so we invent a pattern. We force a system into chaos. And it tricks us. That's the gambler's fallacy, the belief that previous events somehow affect the odds of something inherently random, but probability doesn't care about the past, and that's why it breaks our intuition. Let's go deeper. Imagine you have 2 kids. What's the chance they're both boys? Simple, 50% chance for a boy, 50% for a girl, so both boys, half of a half, 25%. Easy. Now here's the twist. Someone says, I have 2 kids, at least one is a boy. What's the probability both are boys? Most people say 50%, but the answer is 1 in 3. Why? Because once you know that one is a boy, that removes one option, girl plus girl. But it still leaves boy plus girl, and girl plus boy. 3 possibilities. Only one of them has 2 boys, so 1 in 3, that doesn't feel natural, but it's true. Probability isn't just about odds, it's about information. The more you know, the more the odds change. The less you know, the more your guesses can betray you. Let's take it further, Monty Hall problem. It's legendary for confusing even trained mathematicians. You're on a game show. There are 3 doors, behind one is a car, behind the other 2 goats. You choose one door. Then the host opens one of the other doors and shows a goat. Now he asks, do you want to switch or stay? Your instinct says it's 50-50 now, 1 car, 2 doors, equal chance. But no, if you switch, your chances go up to 2/3. If you stay, it's 1/3. The host knows where the car is. He always opens a goat door, so when he does that, he's giving you extra information. And switching takes advantage of that, but most people stick with their first choice, because they trust their gut, not the math. That's the point. Probability punishes instinct, rewards logic. But our brains evolved for survival, not statistics. Now let's look at something more emotional, medical testing. You take a test that's 99% accurate. It says you're positive for a rare disease. Should you panic? Probably not. Here, SY. Let's say only 1 in 10,000 people actually has the disease. The test is 99% accurate, meaning 1% false positives. If 10,000 people take the test, only 1 truly has the disease. But 1% of the rest, that's 99 people, will get a false positive. So out of 100 positive results, only 1 is real. The rest are false alarms. So your actual chance of having the disease, even with a positive result, is 1 in 100. Not 99%, 1%. This is called base rate neglect, ignoring how rare something is and trusting the surface number instead. It happens all the time, in health, in crime, in news. A statistic looks scary, but if the base rate is low, the real risk is tiny. And yet we react emotionally. We panic, because our minds are wired for short-term threats, not long-term nuance. Now let's talk quantum. At the smallest level of reality, probability isn't just uncertainty, it's fundamental. In quantum mechanics, particles don't have a fixed position or speed until you measure them. Instead, they exist in a cloud of probabilities. Until you look, they're nowhere and everywhere at once. It's not just that you don't know where the particle is, it's that the particle itself doesn't know where it is, not until you ask. That's the core of Heisenberg's uncertainty principle. There's a limit to how much you can know, not because your tools are bad, but because reality itself doesn't offer full knowledge. And probability is the language of that limit. So imagine that reality isn't a fixed script, it's a lottery, every particle, every interaction, a spin of the dice. Probability isn't the shadow of ignorance, it's the blueprint of existence. Let's look at another mind bender, Schrödinger's cat. A cat is put in a sealed box. Inside is a radioactive atom with a 50% chance of decaying and triggering poison. After some time, without opening the box, the cat is both alive and dead, not metaphorically, but literally, according to the math. Only when you open the box, when you measure, does the system collapse into one state. It sounds absurd, but this isn't philosophy. This is the actual behavior of quantum particles, and it's probability that dictates the outcome. Reality doesn't decide until you check. So think about that. The universe doesn't choose an outcome, it waits for you to look. Until then, all possibilities coexist. Now let's jump from physics to weather. You check your phone, it says 40% chance of rain. What does that mean? Most people think it'll rain 40% of the time, or it'll rain in 40% of the area, but the actual meaning is simpler and stranger. It means under similar conditions, it rained 4 out of 10 times, that's it. It doesn't say anything about this specific day. Just that if this exact situation happened again and again, 40% of the time, rain followed. Probability is pattern over time, not prediction. You can't use it to say what will happen, only what might and how often. And that's where probability breaks our human instincts again. We want certainty. Yes or no? Will it rain or not? Will the treatment work or not? Will the plane crash or not? But probability doesn't give guarantees, it gives risk, range, confidence, and most people don't know how to live with that. Now let's get personal. Think about your own life. How did you meet your closest friend? How did you end up in your job? What chain of tiny events led to your current situation? A missed bus, a phone call, a stranger in a coffee shop. So many things that weren't planned, that couldn't be predicted, that had no certainty, just chance. We treat our lives as if they're logical progressions. But behind almost every major turning point is randomness, coincidence, a lucky break or an unlucky one. You were born in this country to those parents in that hospital out of billions of possibilities. Every day, the trajectory of your life is nudged by invisible dice. But because we hate the idea of randomness, we create stories. We say meant to be, or destiny, or bad luck. But it's just probability wearing a human mask. And here's one final twist. In science, probability can be precise, but in life, it's often invisible. We don't see the alternate paths, the choices not taken, the accidents that never happened, so we think we understand what's happening, but really, we're just walking the path that did happen, not knowing how rare or likely it really was. So if randomness controls quantum particles, if rain forecasts describe chance, not certainty, if the same test can give false alarms, if a fair coin can land heads 10 times in a row, if your biggest life moments were shaped by chance, if your brain keeps inventing patterns where none exist, then maybe probability isn't just math. Maybe it's reality's way of reminding us that control is an illusion, and that every moment, no matter how ordinary, is the outcome of countless invisible dice you didn't even know were rolling. Zero seems harmless, just a number, a placeholder, nothing, but the more you look at it, the more it starts to tear things apart. Because zero isn't just empty space, it's a concept that breaks the rules of everything we thought we understood. And it's the only number that means something by representing nothing. That alone makes it strange. But when you start using it in math, in physics, in real life, you find out it's not just strange, it's dangerous. Let's start simple. You have 3 apples, you give away 3, now you have 0, nothing in your hand makes sense. But rewind 2,000 years and that sentence would have made no sense at all. Most ancient civilizations didn't have a 0, the Greeks didn't, the Romans didn't. Try writing 0 in Roman numerals, you can't. Because to them the idea of nothing wasn't a number, it was a lack, a void. You don't count nothing, you just don't count. So where did 0 come from? India, around the 5th century. Mathematicians there started using a small dot underneath numbers to mark an empty place. That dot became 0, not a blank space, but an actual digit, and that changed everything, because now nothing had a name, a symbol, a role in equations, and once it had a name, we could start doing things with it. Now here's where it gets weird. Addition with 0, easy. 5 plus 0 is 5, no change. Multiplication, fine. 5 times 0 is 0, everything disappears. But then comes division. Try dividing 5 by 0. Your calculator says error. Try dividing 0 by 0, same thing. Not because it's hard to calculate, but because the concept itself doesn't make sense. You're trying to split something into no parts, or nothing into nothing. The result isn't infinity, it's undefined. The system breaks. And that's the first crack, because math is supposed to be logical, ordered, but one number, one symbol makes it fall apart. Try to divide by 0 and the whole equation collapses. That's not just a bug, it's a structural weakness. A blind spot in the system we trust more than any other. Let's go further. In calculus, 0 shows up everywhere. Limits, derivatives, instantaneous change. You want to know how fast something is going right now, not after a second, not over a minute, but this exact instant. You need 0. You need to measure over an interval so small it's practically nothing. That's the whole idea of a limit. You approach 0, get infinitely close, but never reach it, because if you do, the equation blows up. Now think about physics. You've heard of absolute 0, the coldest possible temperature. 0 Kelvin, the point where particles stop moving, literally no kinetic energy. But here's the thing, we've never reached it, and we probably never will, because the closer you get to absolute 0, the harder it becomes to extract any more heat. Every effort gives you less and less progress. It's like chasing a finish line that keeps shrinking. So 0 isn't just a concept, it's a wall. An unreachable boundary that physics respects but can't touch. Now let's talk about black holes. These cosmic monsters collapse matter into a single point, a singularity, with 0 volume and infinite density. Wait, 0 volume but infinite mass? How does that work? It doesn't. It's another place where math says I don't know. The equations break, gravity becomes infinite, space and time twist into nonsense. And all because something went down to 0, in this case, the size of the object. 0 isn't harmless, it's the trigger for paradoxes. Dividing by it creates chaos. Multiplying by it makes everything vanish. Approaching it creates asymptotes, those weird curves that get closer and closer but never touch. 0 is the mathematical version of a cliff. One step too far, and you're falling into undefined territory. Now think about existence. If you have one object, it exists. If you have 0, it doesn't. So 0 defines presence. It draws the line between being and non-being, between something and nothing. But what is nothing? Can nothing actually exist? Quantum physics says no. Even a perfect vacuum, a space with 0 matter, still has fluctuations. Tiny particles pop in and out of existence. It's called quantum foam. So even nothing isn't really nothing. It's just another name for something we don't understand. And 0 becomes an illusion. But we treat it like it's real. We build around it. 0 in your bank account, no money. 0 in your engine, no speed. 0 in your blood pressure, no pulse. It's not just a number, it's a signal, a warning, a stop. Even in coding, zero is critical. Computers run on ones and zeros, on and off, signal and silence. The entire digital world is built on the difference between something and nothing. And yet, when a program divides by zero, it crashes, because even machines can't escape that paradox. Now look at history. The arrival of zero in Europe was met with resistance. Ch. Authorities were suspicious of it. Merchants didn't trust it. Why would you want a number that means nothing? But mathematicians knew better. Zero made calculations easier, made accounting cleaner, made algebra possible. Try solving equations without zero. Try defining negative numbers. Try building a coordinate system. None of it works without that one strange symbol. Zero made place value possible. Without it, 102 and 12 look the same. But with it, you know where things stand. It's not just empty space. It's a placeholder, a structural tool. It holds everything else in position. And yet it remains fragile. You can't touch it. You can't see it. You can't divide by it. You can't reach it in temperature. You can't escape it in physics. You can't fully define it in logic. And here's the final twist. In modern math, we still struggle with what zero really is. Is it a number, a symbol, a concept? Is it the absence of quantity or the quantity of absence? You can subtract one from one and get zero, but can you subtract a universe from a universe and get nothing? Is it possible to remove everything, truly everything, and be left with zero, or is there always something, some field, some space, some potential, even in emptiness? And if zero isn't just a number, if it creates paradox when you divide, if it stops time at absolute zero, if it bends space into singularity, if it shapes every digital system, if it builds and breaks equations, if even a vacuum isn't truly empty, then maybe zero isn't nothing at all. Maybe it's the most loaded number we've ever invented, the symbol we use when we have no idea what's really there. Numbers feel like the most solid thing in the world. One apple, two shoes, three people, you don't question it. Numbers are just there, always have been, always will be. They're the foundation of science, economy, logic. Everything can be counted. Everything can be measured. But the moment you stop and ask where numbers actually come from, the whole picture begins to shake. Let's start with something basic. You have one object, then another. You count 1, 2. That feels natural. But 2 isn't something you can touch. You can hold 2 coins, 2 rocks, 2 chairs, but the 2 itself, it's not real, it's an idea. A label we put on collections. You never touch the number, you just touch the objects. And yet we act like numbers are real. We use them to measure temperature, speed, distance, weight. We say the universe is made of math, that numbers are the language of reality. But here's the catch. Every single number is a human invention. Numbers didn't come with the universe. We created them. Think about it, the concept of 3 didn't exist before someone invented the word. Different cultures counted differently. Some tribes only had words for 1, 2, and many. The Mayans used a base 20 system. Babylonians used base 60. Computers use base 2. There's nothing universal about the number system we use. It's a historical tool, a convention. Even zero had to be invented. Ancient Greeks didn't use it. Romans didn't have a symbol for it. It was India that gave us zero, a placeholder for nothing. And Europe resisted it for centuries, because it was too strange, too abstract, too empty. Now we treat it as normal, but it wasn't always normal. Then there's the question of fractions. 1/2, 1/3, what do those even mean? You can't cut everything in half. Try slicing a cloud, try dividing a sound, but we use fractions all the time, because they help us describe what we can't hold. Go deeper and you hit irrational numbers, like pi, like the square root of 2, numbers that never end, never repeat. You can't write them out, you can't finish them, they go on forever. And yet we use them, we build bridges with them, launch rockets, run simulations, all using numbers that can't be fully known. Take pi, it starts with 3.14, but the decimals never stop. It's been computed to trillions of digits and still goes on. You can never find its final digit, but it's baked into the formula for circles. Every wheel, every sphere, every orbit is built on an unknowable number. Same with the square root of 2. It's the length of the diagonal of a square with sides of 1. But it can't be written as a fraction. It's irrational, infinite, so we round it, we approximate, we pretend we know, but we don't. Now let's talk about imaginary numbers. Numbers that are literally called imaginary, like the square root of -1. It doesn't exist on the real number line, but in electrical engineering, signal processing, quantum physics, imaginary numbers are essential. They make the equations work. They describe real things, real systems, but they themselves aren't real. So we have real numbers we can't finish, imaginary numbers that work, and whole numbers that don't actually exist in nature. Ask yourself, what is 5? Not 5 objects, just the 5 itself. It's a symbol, a concept. Nothing in the universe is 5. It can have 5 parts, but the number isn't in the thing, it's in your mind. And yet we treat numbers as truth. We run science on them. We run economies. We vote. We measure. We optimize. But if the numbers are built on systems we invented, what exactly are we trusting? Then comes the idea of infinity. It's not a number, but we treat it like one. We say numbers go on forever, that there's always a bigger one, that the number line never ends. But has anyone ever seen infinity? Has anyone counted that far? And if numbers never end, how can we claim to know anything about all of them? We've only touched a sliver. We've never seen the whole line, but we draw it anyway, as if it stretches across the universe. Now let's flip it. What about the smallest numbers? Can you divide forever? Can you keep having something forever and never reach zero? That's what math says, that numbers are infinitely divisible, but physics says no. At some point you hit Planck length, the smallest possible unit of space. Below that, reality breaks, so math says keep going, but the universe says stop. So numbers which feel infinite may actually have limits, limits on how small they can get, limits on what they describe, because while the number line is smooth, reality is not. The world is made of particles, quanta, steps. And then comes Gödel, a mathematician who showed that no system of numbers can prove all the truths within itself, that in any mathematical system strong enough to do basic arithmetic, there will always be true statements that can't be proven. Meaning, numbers are incomplete, they're powerful, but not perfect. And yet we use them for everything. We rate movies from 1 to 10, we give people IQ scores, we grade students with percentages, we calculate risk, reward, love, success, all with numbers. We act like if it's measurable, it's real, and if it's not measurable, it's suspicious. But what if numbers don't describe the world? What if they shape it? What if the moment you attach a number to something, you change how people treat it? A test score becomes identity, a salary becomes value, a social media follower count becomes worth. Numbers turn into symbols, symbols turn into beliefs, beliefs turn into systems, and then we forget the numbers were made up in the first place. So let's pull back. If different cultures used different systems, if zero had to be invented, if irrational and imaginary numbers can't be fully known, if infinities break equations, if Gödel proved math has holes, if even physics says numbers might not match reality, then maybe numbers aren't the foundation of truth. Maybe they're the scaffolding, the map, not the territory, a human invention so clever, so useful, we forgot it was invented at all. And if that's true, then what exactly are you measuring when you measure your life with numbers? Change is everywhere, every second something shifts, leaves fall, clocks tick, thoughts come and go, you age, the world spins, and yet for something so constant, change is something we deeply struggle to understand, not just emotionally but logically. Because when you start asking what change really is, things get slippery fast. Let's start simple. You pour cold water into a kettle. You turn on the stove. 10 minutes later, it's boiling. Clearly, something changed. The water went from cold to hot, but what exactly happened? The molecules moved faster. They absorbed energy. But who decides when it officially became hot? What moment marked the shift? At what temperature did it stop being cold and start being hot? There's no clean border, no fixed line. Change doesn't happen in one click. It's gradual. But the way we think about it, we want that click, that before and after. We want to say, here is where it changed. Same with people. Think about yourself 5 years ago. Different habits, different thoughts, different fears. That person in many ways isn't you anymore. And yet you didn't wake up one day and suddenly change. It happened slowly, one thought at a time, one new experience at a time, until one day you looked back and didn't recognize the old you. But which exact moment was the change? When did it happen? You can't point to it. That's the illusion. We only notice change once it's already far behind us. And here's where it gets even trickier. If change is constant, then what isn't changing? What's staying still? You can only notice change if something else stays the same. But if everything is changing, then what is it changing from? You start to realize to define change, you need stability. But to define stability, you need change. You can't have one without the other. They define each other, and that's a loop. Now let's go to physics. Newton's first law says that an object will stay at rest or keep moving in a straight line unless a force acts on it, which means nothing changes without a push. Change requires cause, energy, a nudge, but what about in quantum mechanics? At the tiniest level, particles change states randomly. They jump, disappear, reappear without any clear cause, no force, no push, just change, spontaneous, which means even the laws of physics can't fully explain all change. At some level, change just happens. And yet we're obsessed with control. With planning, organizing, forecasting, we want to predict change, we want to control the outcome. But over and over, life proves that most change is unpredictable. You fall in love when you didn't expect to. You lose someone suddenly. You make a decision that feels small but changes your entire path. Some of the biggest shifts in your life came from things you didn't see coming, which means the most important changes are often the ones you don't plan. But that doesn't stop us from trying. Whole industries are built around managing change. Therapy, consulting, planning, optimization. But deep down, the one truth we all know is this: you can't stop it. You can delay it, avoid it, ignore it, but change keeps coming. And that creates tension, because we want stability. We want routines, identities, labels. This is who I am. This is what I do. But change laughs at that. Change doesn't ask permission. One phone call can change your life, one mistake, one opportunity, one thought, and suddenly the identity you clung to doesn't fit anymore. So then the question becomes, if you're always changing, who are you? If every cell in your body replaces itself over time, if your beliefs evolve, if your memories fade or shift, what part of you is the real you? Or are you just the sum of all your past changes, pretending to be stable? And this isn't just personal, it's universal. Stars explode, mountains erode, species evolve, civilizations rise and fall, everything is in motion. Even atoms are 99.9999% empty space, vibrating, fluctuating, moving. Nothing sits still, not really. So if everything is always changing, why do we keep expecting permanence? Because we need it psychologically, emotionally. Permanence gives us comfort. It helps us plan, helps us feel safe. But it's an illusion. There's no final version of yourself, no finished career, no fixed relationship. Everything, even if it looks solid, is in motion. Slowly, quietly, constantly. That's why people struggle so much with change, not because change is bad, but because it shatters the illusion of stability. It reminds you that nothing is forever, not even you, and that's scary, but it's also freeing, because if nothing is permanent, then mistakes don't last forever. Pain doesn't, failure doesn't, you always get to begin again. And change has a strange paradox. The more you resist it, the harder it hits, but the more you accept it, the easier it flows. People who adapt survive, people who evolve grow, and the ones who cling to the P. As the break. So if everything is always changing, if no state is permanent, if even the atoms in your body are never still, if your identity is a fluid story made of moving pieces, if time itself is just a measure of how much has changed, then maybe the question isn't, how do I stop change? Maybe it's, what would life be if nothing ever did? Dimensions feel like one of those things we never question. You walk across a room, reach out to grab something, or lie down on a bed, and without even thinking, you're using space. Forward and back, left and right, up and down, 3 directions, 3 axes, 3 dimensions. It feels so natural we don't even notice it. But stop for a second. Why 3? Why not 2 or 4 or 20? Who said the universe must be built this way? Because the moment you start asking that, the simple idea of space starts to fall apart. Let's start small. Imagine a piece of paper, flat, 2 dimensions. It has width and height but no depth. You can draw on it, write on it, fold it, but everything stays on the surface. Now draw a stick figure. That stick figure lives in 2 dimensions. It knows nothing of up. If you reach in and poke the paper from above, the figure might see a strange circle appear and disappear. It wouldn't see your finger. It wouldn't know what hit it. Because your 3rd dimension is completely outside its world, and that's the first clue. If a 2-dimensional being can't see or understand a 3rd dimension, what makes you so sure you can see all the ones that exist? You might be the stick figure, just in a fancier world, and physics agrees. In fact, one of the most mind-bending ideas in modern theoretical physics is that the universe might have more than 3 spatial dimensions. String theory, one of the major candidates for a unified theory of everything, requires extra dimensions for the math to work. Not just 1 extra, not just 2. But 6 or 7 extra dimensions in addition to the 3 we already know. That's a total of 10 or 11 dimensions of space and time. But if they exist, where are they? Why don't we see them? The answer lies in size. These extra dimensions, according to theory, are compactified, curled up so small that they're hidden. Imagine a tight roll of string. From far away it looks like a line, one-dimensional, but up close you see it has width. You can spin around it. It's really 2-dimensional. Now imagine space itself is like that string. We see 3 directions, but maybe there are more hidden in tiny curls at every point in space. You are surrounded by dimensions you can't access, living in a bigger reality than you realize. Still not convinced? Let's go back to our stick figure. What would happen if a three-dimensional object passed through its world? Imagine dropping a ball through the paper. The stick figure wouldn't see a ball, it would see a point appear, then a growing circle, then a shrinking circle, then nothing. It would have no idea what it just witnessed. To us, it's just a ball passing through. But to the figure, it's a mystery, a miracle, or maybe even a threat. Now flip the situation. What if you saw something blink into existence, grow, shrink, and vanish again all in an instant? You might say it's a ghost, or hallucination, or quantum randomness. But maybe, just maybe, it's a four-dimensional object passing through your three-dimensional world. Maybe what we call strange phenomena are just shadows of higher dimensions. Let's talk about time. Time is often called the fourth dimension. And in a way it is. It's a direction. It has an order. You move through it, but not like space. Can't go backward, you can't turn, you can't pause. Time only flows forward, or so it seems. But what if that's just how we're built? What if time is a dimension like any other, but our minds are stuck in one direction? Some theories suggest that all time exists at once, and our consciousness simply rides the wave 1 second at a time. That past, present, and future already exist, but we only experience now. That would mean your entire life, every moment, is already laid out. You're just flipping through the pages, and if that's true, then time isn't moving. Your awareness is the traveler, but the path is already there. It gets deeper. In relativity, time and space are connected. They form one thing, space-time. And space-time isn't flat. It bends, curves, warps around mass and energy. That's gravity. The Earth bends space-time and objects fall into that curve. Light bends too. Time slows down near massive objects. That's why your clock ticks slightly slower on the ground floor than on the top of a skyscraper. Because gravity affects time. That's not theory, that's experiment. That's why GPS satellites have to correct their clocks daily, because time flows differently up there than down here. Which means dimensions aren't just ideas, they're real. They change how the world works. They change how you move, how you age, how you live. Now let's imagine a fourth spatial dimension. Not time, but another direction you can't see. You wouldn't notice it, but objects might behave strangely. Appear, disappear, shift without cause, maybe even teleport. Sound like science fiction? Maybe. But in higher dimensional spaces, those are normal behaviors. A cube in 3 dimensions becomes a tesseract in 4, and a tesseract can rotate in ways that seem impossible, because it's rotating through directions we can't imagine, just like a square can't imagine depth. So how would a 4-dimensional being see you? Not just your body, but your insides, your cells, your memories, your timeline all at once. To them, you'd be like a book, not a person. Your entire life visible, not moment by moment, but all pages at the same time. Now think about this. If something higher dimensional exists, it wouldn't be bound by the same rules. It might see your birth, your death, and everything in between instantly. It could poke through our world in strange ways, appear as visions or shapes or impossible structures. You wouldn't be able to interact with it, but you know something happened. That's what higher dimensions mean. They're not just directions, they're entire ways of being, entire levels of existence. And you might be bumping into them without knowing. In quantum mechanics, particles can pop in and out of existence. They can be entangled, communicating instantly across distance. They behave like waves and particles at once. It doesn't make sense unless there's more happening than we can see. Some physicists believe these quantum behaviors could be hints of higher dimensions, that the randomness is just perspective, that from a higher view, it all fits. And then comes the holographic principle. A theory that suggests everything inside a volume of space can be described by data on its boundary. Meaning you, your room, your entire reality could be a projection from a higher dimensional surface, like a hologram, not metaphorically. Literally, we might be shadows of a deeper truth, a 3-dimensional echo of a higher reality. And if that's true, then space isn't what we think. Then you're not where you think you are. You're not a being inside space. You're a slice, a frame, a part of something bigger. Something you can't see and maybe never will. So what are dimensions really? They're not just measurements. They're the fabric of reality, the scaffolding of everything. And the more we learn, the more we realize how little we know. If a 2-dimensional being can't see up and a 3-dimensional being can't see 4, what makes you think this is all there is? Maybe you're missing something. Maybe you're surrounded by something. Maybe the cracks in logic, the paradoxes in physics, the gaps in understanding, maybe they all come from not seeing the full picture. Because you're not in full space. You're in a shadow, a layer, a slice of something with more. So if string theory needs extra dimensions, if black holes bend reality through space and time, if quantum mechanics hints at hidden interactions, if math allows rotations we can't imagine, if consciousness flows through a timeline that might already exist. If the GPS in your phone depends on the bending of time itself, if you've never seen more than 3 directions, but the math demands more, then maybe the real question is, how many dimensions are there? Maybe the question is, how many do you live in without knowing? Walk into a room and hear a ticking clock. Tick, tick, tick. At first, it's just background noise, but after a while, you start predicting it. You know exactly when the next tick will come. That's a pattern, a sequence, a rhythm, and the human brain is obsessed with it. Because recognizing patterns means survival. If the sun rises after the night, you wake up. If an animal runs when you approach, you hunt. If a look from someone always means trouble, you avoid. Pattern isn't just design. It's prediction, it's knowing what comes next, and from a young age, you're trained to spot it. A child sees red, yellow, and knows the next color is red. That's not math, that's the mind craving structure, and the world is full of it. The seasons, the tides, the growth of plants, the formation of snowflakes, patterns everywhere. But here's the strange part. Once you see a pattern, you start expecting it, even when it's not real. Think about the last time you saw a face in a cloud, or a shape in the shadows, or heard your phone buzz but it didn't. That's called pareidolia. Your brain tries to make sense of noise by turning it into a pattern. It hates randomness. It fills the gaps, even if it means making up something that's not there. That's why gamblers think a machine is due for a win. That's why people see signs in numbers, omens in coincidences, meaning in chaos. The pattern feels real even when it is. And that's where it breaks, because your brain isn't a logic machine, it's a prediction engine. It would rather see a false pattern than miss a real one. And that instinct, which helped us survive for thousands of years, now backfires. In statistics, this is called apophenia, seeing patterns in randomness. Imagine flipping a coin. It lands heads 5 times, you think tails must be next, but the coin doesn't remember. Each flip is independent, but your brain insists there's a pattern. And that belief can cost you. Go deeper, look at the stock market, charts, candles, trends. People build entire systems to predict what's next. Technical analysis, Fibonacci levels, golden crosses, but here's the catch, most of those systems are retroactive. They work after the fact. You can always find a pattern that fits the past. But that doesn't mean it predicts the future, because the market isn't a machine. It's a million human decisions, and humans are not always rational. That's the illusion of pattern. It looks clear until it doesn't. And now think about conspiracy theories. People connect events across time. Headlines, accidents, quotes, symbols, they form a web, a picture, a story, it all adds up. But just because something fits a pattern doesn't mean it's true. You can connect dots anywhere. The human mind is so good at it, it can make sense of pure nonsense. That's what happens in the Rorschach test. People look at ink blots and see monsters, lovers, animals, because the brain doesn't like blanks. It needs to fill them, but here's the twist, pattern detection isn't just a flaw, it's the foundation of science. Every law of physics started with someone spotting a pattern. Apples fall, so do stones, so do planets. Newton connected the dots, that's gravity. Mendeleev saw recurring properties in elements and created the periodic table. Darwin saw similarities in species and found evolution. Science is the art of turning patterns into principles, but it requires one thing, falsifiability. A real pattern can be tested, it can fail, it can be proven wrong. That's how you separate a useful pattern from a comforting illusion. Because once a pattern survives testing, it becomes a law, but if it breaks under pressure, it was never real. So now we ask, how many of the patterns we believe are just noise? You hear about the rule of threes in storytelling, that jokes land better in threes, that tragedies come in threes. But is that a real structure or just selected memory? You remember the 3 famous deaths, but not the 4 quiet ones. That's pattern bias. You're not seeing what's there, you're seeing what fits. And sometimes that blindness gets dangerous. Consider medicine. If a doctor expects a pattern, they might miss a symptom that breaks it. A patient with chest pain is assumed to have a heart problem. But what if it's something else? The mind fills in the expected story, and reality slips by. That's why pattern recognition must be balanced with skepticism. You need to ask, am I seeing this because it's there, or because I want it to be? Now here's where it gets even more complex. Some patterns are so deep you can't see them, but they shape your entire world, like the Fibonacci sequence in nature. The spiral of a sunflower, the arrangement of leaves, the curve of a seashell, they all follow the same ratio. The golden ratio, around 1.618, a pattern that appears again and again in the physical world, not because it's magical, but because it's efficient. It's how Ustoms grow, spiral galaxies, hurricanes, even the shape of your ear, pattern not as art but as structure, as biology, as optimization. And that same ratio appears in music, in architecture, in design, not because it was forced but because it feels right. It's pleasing to the brain, it flows. But even then you have to ask, is that because we evolved in a world shaped by that ratio, or because we shaped the world in a way that fits it? Are we finding the pattern or imposing it? And that question leads to the biggest crack of all. If everything is a pattern, where's the chaos? If everything has order, where's the freedom? Because if patterns dictate behavior, structure, movement, growth, then are we just following scripts? Is your life a pattern you didn't write? Wake up, check phone, brush teeth, work, eat, scroll, sleep, repeat. That's not a routine, that's a pattern. And the more you repeat it, the harder it becomes to change. Habits are patterns, beliefs are patterns. Even your sense of self is a pattern of memories, thoughts, reactions. So if you want to change your life, you have to break the pattern. But here's the catch. You can't break a pattern unless you first see it. Most people don't know the pattern they're in, they feel stuck. But they don't know why. That's because patterns aren't just visible, they're emotional. You argue with your partner in the same way every time. You get sad for no reason at the same time every week. You sabotage your own goals just before you get close. That's not a coincidence. That's a script running in the background. And until you recognize it, it keeps running. But now flip it, patterns can also save you. In music, rhythm is a pattern, without it just noise. In language, grammar is a pattern, without it nonsense. In sports, training builds muscle memory, which is just another pattern. Patterns create flow, predictability, mastery. A dancer doesn't think about each move, they feel the sequence, because the pattern is inside them, burned in. So the real question isn't whether patterns are good or bad, it's whether you're aware of them, whether you can tell the difference between a real one and an illusion, whether you're using the pattern or the pattern is using you. Because if your thoughts are habits, and your habits are patterns, and your identity is shaped by what repeats, then maybe the only way to truly change your life is to find the pattern underneath it all and choose a new one. And that brings us to the final question. If your brain sees patterns even when they're not real, and if your life follows patterns you didn't consciously design, then how much of what you call you is just repetition in disguise? You've seen them your whole life, on the beach, in the bathtub, in the air, on your phone. Waves are everywhere, but the more you look, the less they make sense. Because a wave isn't a thing, it's a motion, a shape, a disturbance, a transfer of energy with no solid object behind it, which makes it one of the most powerful forces in the universe, built out of nothing solid at all. Let's start simple. You throw a rock in a lake, circles spread out, that's a wave, but what actually moved, not the water. If you follow one droplet, it just bobs up and down, it never travels far. The shape moves, the energy moves, but the particles don't. That's the first strange part. A wave moves without carrying stuff, it moves through stuff. Sound is the same. When you talk, your vocal cords push the air. That pressure travels through the room, but the air doesn't go anywhere. It vibrates, compresses, expands. Your voice rides that pressure, but no air molecule traveled from your mouth to their ears. The shape traveled, the pattern traveled. That's what sound is, a pressure wave moving through the air. And the same thing happens in solids and liquids. Knock on a wall and it sends vibrations. Slam a door and it sends pressure through the air. But in all those cases, the stuff stays still. The wave doesn't. That means a wave is energy moving through matter. It's not a particle, it's not a thing, it's a disturbance. That alone is weird enough, but then come the types. There are two main kinds of mechanical waves, transverse and longitudinal. In transverse waves, like water waves or light, the vibration is perpendicular to the direction of travel. In longitudinal waves, like sound, the vibration is in the same direction the wave moves. Picture someone shaking a rope up and down, that's transverse. Now imagine compressing a spring, push and release, that's longitudinal. Both move energy, both move patterns, but not mass. And then there are surface waves, like what you see on oceans. Those are a mix. The particles move in circles. Energy goes one way, water swirls around it, so even the most basic wave is a complex hybrid. But it gets crazier. Because waves don't just travel, they bounce, they bend, they interfere. You drop two rocks in a pond, their waves cross. Where the peaks meet, they get bigger. Where a peak meets a trough, they cancel, that's interference. And it leads to patterns no single wave could make. Sometimes they amplify, sometimes they destroy each other. Two weak signals, when perfectly out of phase, can equal silence. Two strong signals, when aligned, can become massive. This is how noise-canceling headphones work. They don't block sound, they create waves that cancel incoming ones. So silence becomes an active creation. But now enter light. Light behaves like a wave. It bends around corners, it interferes with itself. Shine it through two slits and you get an interference pattern. Bright, dark, but light also behaves like a particle. It hits things one photon at a time, it knocks electrons loose, it transfers energy in discrete packets. So what is it? This is the famous wave-particle duality, the idea that light and everything else in quantum mechanics is both a wave and a particle, not either or both at once until measured. It gets more bizarre. Fire single photons at a time, one by one, at the double slit. Each photon makes a dot. But over time, those dots build up an interference pattern like a wave, so even one particle alone somehow knows the pattern, as if it's interfering with itself. How can a single particle create a wave-like pattern unless it is a wave? This is not metaphor. This is measured, observed, repeated. In 1924, Louis de Broglie proposed that not only does light behave like a wave, but matter does too. Electrons, protons, even molecules, and it was confirmed. You can fire electrons at a crystal and they diffract, create wave patterns. Matter has wavelength. And here's the part that breaks intuition. The smaller the particle's momentum, the longer its wavelength. This is called the de Broglie wavelength. It's incredibly tiny for large objects, so you never notice it in people or baseballs, but it's there, mathematically, physically, measurably for tiny particles. That means everything is, in some sense, a wave, even you. Now go deeper. In quantum mechanics, everything is described by a wave function, a mathematical description that tells you where a particle might be and what it might be doing. But this wave isn't physical, it's a probability wave, meaning it doesn't tell you where the particle is, it tells you where it could be. The wave spreads out, and until you measure, the particle exists in all those places at once, like a ripple of chances, collapsing into a point only when observed. So again, wave, but not like anything we know, a wave of possibility, a wave of outcomes, a wave in. Odd in space, but in knowledge. Now think of radio, you tune to frequency. You don't move, you don't go find the station. You just adjust your receiver and the waves already filling the space become audible. The signal was always there, you just align to it. That's the essence of resonance. Every object has a natural frequency, a way it wants to vibrate. Hit that note and it comes alive. Push a child on a swing at just the right rhythm and the swing gets higher and higher. Push at the wrong time and nothing happens. This is resonance. The transfer of energy becomes easy, effortless, when the wave matches the natural rhythm. This is why bridges collapse when soldiers march in sync, why wine glasses shatter when singers hit the right note, why microwaves heat food. The wave matches something inside, and it explodes with energy. And it's not just physics. Your brain rides on waves. Brainwaves, electrical patterns that oscillate at different frequencies depending on your mood, alertness, or sleep state. Alpha waves, beta waves, theta waves, these aren't imaginary. They're measured. Your thoughts, your awareness ride waves. Your hearing depends on pressure waves. Your vision depends on electromagnetic waves. Your balance depends on fluid waves in your inner ear. You are in every sense a creature made of and tuned to waves. Even music, it's not the notes. It's the movement between them, the vibrations in the air, the patterns. You don't hear a note, you hear its wave, the frequency, the rhythm. And when those patterns align with your biology, you feel. Emotion is just your body resonating with sound. And now the wild part. According to some interpretations of quantum field theory, all particles are just excitations of underlying fields. There's an electron field, a photon field, a Higgs field, and what we call a particle is just a tiny ripple in that field. Meaning, fundamentally, everything might be waves. You, me, the atoms in your hands, all just stable ripples in invisible fields. That's not philosophy, that's physics. But what about control? Can we ride waves? Yes, every wireless communication is based on manipulating waves. Bluetooth, Wi-Fi, cell signals, data encoded into amplitude, frequency, phase, all surfing the air. You speak into a phone, your voice becomes a wave. That wave becomes a digital signal, travels through the air, gets decoded on the other end, and suddenly your words appear miles away, not as mass, not as matter, but as waves. Lasers, controlled waves, MRI scans, magnetic waves in your body, ultrasound, high-frequency waves bouncing off tissues, earthquakes, shockwaves through rock, tsunamis, ocean waves with unimaginable power, solar flares, bursts of electromagnetic waves from the sun, and gravitational waves. Yes, even spacetime itself can ripple. In 2015, LIGO detected gravitational waves, the stretching and squeezing of the very fabric of the universe caused by colliding black holes. A wave not in water, not in air, but in reality itself. So when you think of waves, don't just think of oceans, think of everything. Every time something vibrates, pulses, oscillates, spreads, bends, or bounces, a wave is born. And if everything is a wave, if sound is vibration in air, if light is vibration in electromagnetic fields, if matter itself is a standing wave in quantum fields, if spacetime ripples under the weight of mass, if thought is electric oscillation in neurons, if every experience you've ever had came through the shape of some wave, then the real question is not what is a wave, the real question is there anything that is? Imagine you're sitting in a silent room, no music, no talking, just quiet. But then you start hearing things, a light buzzing from the ceiling, the fridge hums in the kitchen. Maybe your ears start ringing a little, and deep inside that silence you realize nothing is ever truly still. Everything is vibrating, everything is oscillating, everything has a rhythm, everything has a frequency. But what exactly is frequency? And what if I told you it's not just about sound? It's not just about pitch or music or how fast something wiggles. Frequency is one of the deepest structures of reality. It's not something we just use to describe the world. It's something the world is. And the more you understand that, the more reality starts to behave differently. So let's strip it down. At its core, frequency is just repetition over time. How many times something happens in a second, that's it. Whether it's a wave of sound, a light beam, a heartbeat, or even a signal from your brain, if it repeats, it has a frequency, and frequency is measured in hertz. 1 hertz means 1 cycle per second. 100 hertz means 100 wiggles per second. Easy, but here's the trick. The moment something repeats, the moment there's rhythm, there's structure. There's predictability, there's information, and that's the beginning of the illusion we call stability. Take your voice. When you speak, your vocal cords vibrate. They produce sound waves. These waves travel through the air. The faster the vibration, the higher the pitch. That's why a child's voice is higher than a man's. Their vocal cords vibrate faster. The sound wave has a higher frequency. But what is a sound wave, really? It's just air particles bouncing into each other over and over in a repeating pattern. So when you hear something, you're not hearing the thing itself. You're hearing how often it repeats. You're hearing its frequency. You're decoding vibrations with your ears. You're turning rhythm into meaning, into language, into emotion. Now zoom out. Light is the same thing. It's just a wave, not a sound wave, not an air vibration, but an electromagnetic wave. And just like sound, it has frequency. Red light vibrates slower than blue light. Infrared is slower than red. Ultraviolet is faster than blue. Go slow enough and it becomes radio. Go fast enough and it becomes gamma radiation. The only difference between visible light and deadly radiation is frequency, not the material, not the source, just how fast it vibrates. Frequency isn't just a property of things, it is the thing. Your body understands frequency even if you don't. Your brain emits brainwaves, alpha, beta, theta, delta. Each one corresponds to a different state of consciousness. Focus, sleep, deep meditation, and guess what? They're just electrical pulses with specific frequencies. Sleep doesn't just feel different, it is different. It's a different rhythm, a different tempo, a different vibration. Your brain literally tunes itself like a radio depending on what you're doing. Even your cells vibrate. Molecules, atoms, quarks, everything moves, nothing is fully at rest. Temperature, just a measure of how fast particles are moving. Faster motion, higher frequency, more heat. Cold isn't the absence of heat, it's slower vibration. Stillness is just lower frequency. Everything alive and everything dead has a rhythm, and every rhythm can be tuned, changed, manipulated. Let's talk about resonance. That's when one frequency affects another, like when a singer hits the perfect note and shatters a glass. The sound wave matches the natural frequency of the glass, amplifies it, and boom, it breaks. That's not magic, that's resonance. That's what happens when frequencies align. Two separate things vibrating at the same rhythm suddenly become one. Their energy combines, and sometimes that combination is powerful enough to destroy. Resonance isn't just for opera singers. It's how radios work, how tuning forks work, how MRI machines work, even how atoms absorb and emit energy. It's also how people work. Ever met someone and immediately felt like you were on the same wavelength? That's not just a metaphor. Human brains literally start syncing frequencies when they connect. It's called neural entrainment. In a deep conversation, your brainwaves can start matching the other person's. Same rhythm, same flow. Like two pendulums swinging in sync, like music. And speaking of music, music is just organized frequency. Notes, chords, beats, they're all patterns of vibration, and your body loves patterns. You instinctively move to the beat. Your heart rate syncs. Your brain calms or fires up depending on the rhythm. It's not because you like music, it's because you are music. You're made of frequency, you're not just hearing it, you're responding to it, you are it. But here's where it gets weird. Frequency affects matter. Sound can move objects, ultrasound can break stones, vibration can separate fluids. Even sand on a metal plate forms perfect shapes when exposed to specific tones. They're called Chladni patterns, and they're not random, they're geometrically precise, which means vibration creates structure. Frequency isn't just a property of things, it's an architect, a builder, a sculptor. In 2014, researchers showed that high-frequency sound could levitate particles in midair. That's right, levitate, with no magnets, no strings, just vibration. Sound frequency alone held matter in space. Think about that. Vibration, something intangible, controlling something solid. It flips our understanding. We think of sound as soft, invisible, harmless, but at the right frequency, it has force, power, control. Now ask yourself this: if everything is vibrating, what sets the bass rhythm? What determines the default frequency of reality? Is there a background hum, a cosmic note? Actually, yes, the universe has a frequency. It's called the cosmic microwave background. It's a faint, low-energy signal left over from the Big Bang, and it's everywhere, a kind of universal echo. A frequency so low we can't hear it, but it's there. Always, a memory of the universe's birth, still vibrating. But here's the real question: if the universe has a frequency, can it be tuned? That's the terrifying and fascinating part, because if you can alter frequency, you can alter everything. Tesla once said, if you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. He wasn't being poetic, he meant it literally. Frequency is not a side effect, it's a foundation. Matter is just energy vibrating at a low frequency. Change the frequency, you change the energy. Change the energy, you change the matter. In theory, this means frequency could be used to affect time, gravity, even consciousness itself. That's not science fiction. That's quantum mechanics, that's string theory, that's reality if you zoom in far enough. Because at the smallest scale, particles aren't solid dots. They're waves, strings, vibrations. The difference between one particle and another is just how it vibrates. So again, frequency is not a measurement, it's an identity. In the quantum world, what something is depends on how it moves. So now we come full circle. Frequency isn't about radios, or sound, or music. It's about being, it's the rhythm of existence, the signature of everything, a kind of invisible fingerprint that defines what something is, how it behaves, and how it interacts with everything else. So what happens when your own frequency changes? When you're stressed, your heart rate spikes, your breathing speeds up, your brainwaves go into high-frequency beta mode. When you meditate, everything slows, you shift into alpha or theta, you literally become a different person, not metaphorically. Biologically, neurologically, energetically, you're not thinking differently, you are different because your frequency has shifted. And if that's true, if your mood, your focus, your creativity, even your physical health can change depending on frequency, then maybe everything you are is more flexible than you think. Maybe yourself is just a pattern, a rhythm, a song being played right now but not permanently. What happens when that song changes? Who are you when you're vibrating at a different tune? So let's go deeper. If frequency shapes matter, and if the universe is made of vibrating fields, then frequency is what determines form, not the other way around. That means what you see is just a frozen version of what's moving. Form is illusion, vibration is truth. Even time might be frequency dependent. Time is a measure of change, and change is a shift in state, but what if state itself is just a result of frequency? Then time, too, is downstream from vibration. Faster frequency, faster time. Slower frequency, slower time. It's not just sci-fi, it's physics. Atomic clocks use the frequency of cesium atoms to measure time, and they tick differently depending on gravity and speed. Time doesn't move at a constant rate, it's elastic. Because frequency is elastic, because the universe isn't a ticking clock, it's a vibrating drum. So here's the final thought. What if everything you experience, every sight, every sound, every thought is just your brain tuning into a specific range of frequency? What if reality is a spectrum and you're only seeing one narrow band? Then maybe there are frequencies you haven't noticed, dimensions you can't detect, experiences you can't imagine, not because they don't exist, but because you're not vibrating at the right rate. Maybe enlightenment isn't about seeing more but hearing more, feeling more, vibrating differently. Maybe the secrets of the universe aren't hidden. Maybe they're humming in plain sight. So if reality is just rhythm, if matter is just trapped vibration, then what are you? Imagine touching a metal pole in winter. It burns from cold. Then you touch the same pole in summer. Now it burns from heat. Same object, same atoms, but your brain screams completely different signals. So what changed? The temperature. But what is temperature really? Is it a thing, a number, a sensation, or just an illusion our brains create when particles move faster or slower? You've heard it all your life. Temperature measures how hot or cold something is. But that's not really true. Temperature doesn't measure heat. Temperature is motion. It's the hidden dance behind every solid, every liquid, every gas. And when you finally understand it, temperature stops being a number and starts being a force that shapes reality itself. So let's break it down. First, the simple version. Temperature is the average kinetic energy of particles. That's it. If molecules in a glass of water are moving fast, it's hot. If they're barely moving, it's cold. The number on the thermometer doesn't count particles, it just measures how violently they're bouncing around. More motion, more energy, higher temperature. But that means something weird. Nothing is ever truly cold. Cold is just the absence of motion, the absence of heat. Cold doesn't exist on its own. It's just a word we use when there's not enough movement to notice. And here's where things start to break. Because when you really understand temperature, you realize nothing is still, ever. Even when something feels cold like ice or steel or deep space, its particles are still vibrating, just slower, less intense, but still moving. In fact, the only way something could have no temperature would be if its atoms weren't moving at all, not even a twitch, not even a wiggle. And that brings us to one of the strangest ideas in all of physics, absolute zero. Absolute zero is the lowest possible temperature in the universe. It's not just very cold, it's a fundamental limit, 0 Kelvin, minus 273.15 Celsius. At this temperature, particle motion would stop completely. No vibration, no energy, no time, no entropy, no possibility of change, just perfect stillness. But here's the thing, we've never reached it. We can get close, a billionth of a degree above it, but never all the way. Why? Because the laws of quantum mechanics won't let us. Because even in the quietest, coldest void, the universe refuses to stand still. There's something called zero-point energy. It means even at absolute zero, particles still have a tiny amount of motion, a tiny vibration that never fully disappears, which means the universe has a built-in restlessness, a kind of cosmic fidgeting that can't be shut off. So even in the total absence of heat, temperature never fully vanishes. Stillness is a myth, and if stillness is a myth, then temperature is eternal. But let's go further. Let's ask what temperature does, because it's not just a measurement, it's an architect. Temperature decides everything: the shape of ice crystals, the boiling of water, the color of stars, the behavior of gas in a balloon, the speed of chemical reactions, even the way atoms bond. Temperature tells matter how to behave, not just how to feel, but how to exist. Water freezes at 0 degrees Celsius. But add just a tiny bit of heat, just enough motion, and those rigid ice molecules start shaking loose. They melt, the structure collapses, add more heat and they fly apart completely. They become steam, a gas, the same water but radically different forms, solid, liquid, gas, all decided by nothing more than particle speed. That's temperature in action. And it doesn't just change form, it changes the rules, what's possible, what's stable, what can live. Your body, for example, works only within a tiny temperature range, around 37 degrees Celsius. Go a few degrees up and proteins start breaking down. Go a few degrees down and everything slows. Enzymes stop working. The system collapses. You die, not because the temperature felt wrong, but because the motion of molecules no longer match the code that keeps you alive. Temperature isn't just about comfort. It's about survival, about stability, about whether atoms obey or rebel. And then there's heat. People often confuse heat and temperature, but they're not the same. Temperature is how fast particles are moving. Heat is energy in transit. Heat is what flows from one place to another. Heat moves, temperature describes. When you touch a hot stove, you're not feeling temperature, you're absorbing energy. Molecules in the stove are moving faster than yours, so they smash into your skin molecules, speeding them up. That rush of energy, that transfer, is heat. And the more violent it is, the more pain you feel. That pain isn't from the object. It's from the energy slamming into your nerves, pure motion, pure chaos. No wonder it hurts. Now zoom out, look at the Earth. The sun heats it. The oceans store that heat. The atmosphere moves it around. Wind is just temperature balancing itself. Hot air rises, cold air sinks. Clouds form, storms build, climates change, all because molecules are trying to equalize motion. The entire planet is a system trying to smooth out its temperature, always, eternally, restlessly. And then there's the stars. Stars are born in cold clouds of gas, but gravity compresses them. Pressure builds, temperature rises. At around 15 million degrees, hydrogen atoms slam together so hard they fuse, they become helium. And in that fusion, energy is released: heat, light, radiation. A star is born not from magic but from motion. Enough heat, enough temperature, and matter transforms. Elements are forged, galaxies glow. Without temperature, stars couldn't exist. And without stars, neither could you. In fact, the color of a star tells you its temperature. Red stars are cooler, blue stars are hotter. Our sun is yellow not because it looks that way, but because it's sitting at a specific point in the temperature spectrum. And when stars die, they collapse into white dwarfs or even neutron stars, objects so dense, so hot, so compressed that their temperatures exceed hundreds of millions of degrees. Temperature isn't decoration, it's the script of cosmic evolution. But temperature also creates paradoxes. Like fire, fire is hot, but it's not a thing, it's a reaction, a combustion, a process where molecules break apart, releasing heat as bonds shatter. That energy lights up the air around it. That light is what we see as fire, but fire itself is not an object, it's a performance. A dance of atoms moving so fast that the air glows, a temperature high enough to become visible. Or think about this, why is space cold? If the sun is pouring energy in all directions, why is outer space near absolute zero? Because heat needs something to move through. It needs atoms, particles, a medium, and space is empty. So even though radiation travels through it, there's nothing there to catch the motion. No molecules to jiggle. So the temperature plummets. Space isn't cold because it lacks energy. It's cold because it lacks stuff to hold the energy. But here's where it gets existential. If everything is made of moving particles and temperature is just the speed of that movement, then what happens to temperature in time? The universe is expanding, cooling, the average temperature of space is slowly dropping. One day, far in the future, stars will burn out, energy will spread so thin motion will cease, temperature will approach absolute zero. No light, no heat, no life, a heat death, not an explosion, not a collapse, but a final stillness. A final silence. And that's the ultimate irony. The universe, born in a burst of unimaginable heat, dies in cold. But you're not there yet. Right now, you live in the golden zone, in a narrow band where temperature allows complexity, allows chemistry, allows you. If atoms moved too fast, molecules would never hold together. If they moved too slow, nothing would ever interact. Temperature is the great editor. Too little, nothing happens. Too much, everything burns. You're alive because temperature found balance. But now ask yourself, if temperature is just motion and motion is relative, then is temperature objective? If you travel close to the speed of light, your experience of time slows, distances contract. Could temperature shift too? Could motion, and therefore heat, depend on perspective? Turns out, yes. In physics, there's a concept called the Unruh effect. It predicts that if you accelerate fast enough, really fast, empty space starts to feel warm. That's right. Just by accelerating, you'd feel heat where there should be none. Not because the particles are hotter, but because your frame of reference has changed. That means even temperature, the thing we thought was so simple, so absolute, is so. Here's the truth. Temperature is not just about heat, or cold, or comfort. It's not just a number on a screen. Temperature is the hidden language of reality, the translator between motion and form, the invisible script that tells matter how to act. It controls the stars, it shapes your breath, it even predicts the end of time.